So I think that's also why Anthropic has now announced that they're going to change the model around the pricing of non-interactive usage, most probably because of us and other people doing this stuff. But with a subscription, it's manageable. Because as Yury said, you can just like leave it running and it's going to hit the limit, and once it clears, it's just going to pick up. And then I think it's relatively cheap, but if you run it just with an API access and let it just burn, and it like the npx repo mirror command will show you at the end what the API tells you what it costs, and there we're talking in the hundreds per day.
Hundreds of dollars per day.
Yeah.
Yeah, thank you.
Welcome.
Yeah, I'm getting some technical difficulties with Slido. I'm very sorry. It worked previously. Any other questions from the audience while I fix it? Thank you.
Hello. Did you try the open models to use? I mean, like DeepSeek or like, because it's important.
So I have a little bit of a project with another colleague of mine where we tried to build an NES emulator with the same strategy with Gwen, and that didn't go so well. It always gets stuck at the same point where it's just like, well, I'm running this test and it's doing an infinite loop, and then it starts just guessing some binary addresses and just like cheats its way through, and then the next loop it hits the same issue again, and that's went for days. So frontier models are unfortunately pretty apart still.
Thank you. Yeah, I see a question here.
So how far are you with the provider Crossplane?
Again?
Provider Crossplane? How far are you with that?
I'm building provider tailscale in the background, and it can get to 2 resources with E2E tests in 3 hours. But I also, the problem with all this stuff is that if you just apply the basic Ralph technique with just like a task file as an MD file, and that's all in the terminal, it gets clunky and hard to reason about very quickly. So I'm trying to develop a little bit more of a transparent system where I have like not just files but actual tickets and observe in that way, and that works a little bit better, but it's all very experimental still.
We like experimental.
Nice.
Thank you. I think there's some more questions. We will get to the Slido for sure. It's on the right track. Thank you.
Thank you for the talk. It was really great. My question is, how did you develop these skills? What was the process, and how long did it take to develop the current state?
Not so long, actually. So we actually, so the skills, they're just supposed to streamline what I did manually before. It's pretty much just, there's really no magic involved. They're just like, said like, oh, go to the, clone this Terraform repository, or I can actually give you one tip. Like, if you tell in the prompt, ask user question, at least for Claude, that's Anthropic's tool for putting you up this nice dialogue which asks you questions. And I literally just like did like the VPC module, and when I was done, I was like, well, I want to have this easy to use for other people. So I just like had a little bit of a dialogue, like, okay, I need a step for setting up the project, then I need a step for generating the spec, and so on and so forth. And then I say, ask user question to align, and then the model is so smart that it actually says like, well, do we want to support like on disk or Git? And I say like, well, both. And from there on, I think it took an hour or two, and it's also by no means refined or anything. It's just, it's the first iteration, and I was just stoked that it works at all.
So specifically for Crossplane skills, right? How to build stuff. It's important to show and encapsulate into the skill to show to the agent what is good and what is bad. And we used our reference platform, so actually like a manually crafted previously reference platform as an example of good, right? So that's how we build those skills.
Thank you. any additional questions in the audience? All right, yeah, let me check the Slido. It's already finally progressing. It really worked like when I walked into the room. So now I'm here. Yeah, the question Q&A is open. And there are no questions in the Slido, apparently. Okay, all this for nothing. All right, yeah. Any additional questions? One. Okay, if not, then
thank you so much.
Big applause for Yury. Does it?
Jeden.
Jeden z nich by určitě měl pořád fungovat. Já to ukřičím. Jo, dobře. No, máme minutku do začátku. No, všechno dobrý, mám říct sofany vtipnýho, důležitýho. Mám přitom představení říct soft.
Když máš něco fany, tak to určitě řekni. Myslím, že do srandu tady nebude nouze.
Je tam aj prezenting, ak dá sa pripojiť?
Asi to klidně budu stát a douchat to do toho. Protože já vždycky pak tady jako blbnu si jenom tlačítkem, víš, že se to...
Takže je to len fakt, že dopredu dozadu?
Počkej, to zkusím.
Takže tak po banery.
Jo, takhle. tak jo, to zvládnu. Asi se úplně nestaneš, že jo, ale...
Koho?
Není, jo, teda.
Je.
Jo, ten je.
Jo, dva? Už?
Raz, dva.
Jo.
Jo,
Jo, tak
Perfect. All right. Welcome, everyone. Good morning. We are up in a bit with our second talk from Martin Beránek from Chipmunk, and he will speak about how you can reset databases at scale with Argo. Hundreds of environments, imaginary downtime, and a rational bill. So without further ado, please welcome Martin Beránek with big applause.
Thank you very much for coming. Yeah, I was kind of trying to compete for the longest title of the presentation, but then there is the other one which is longer, so it is what it is. So every great story starts with a problem, you know, obviously. We have a lot of problems, we are problem solvers, that's why we're here. You know, like when you have a thing and you just don't have it anymore, the typical man complex problem which we have to solve every day. I still can't find my crimple pliers. I just put them somewhere. They were there at the moment, but they are not anymore. Laundry is a problem. All of that stuff. But for us, the problem shouldn't be copying the databases, right? This is the example from Postgres. That's so sweet, right? You have like a source template, database, you are using, you know, some production or something, and you would like to create a new database with entirely the same content, all the data, all the schemas, all the stuff, and you just write this little command and you are done. It's just amazing. And I would really like to appreciate these 2 lines, because the rest of the presentation, the rest of 30 minutes you are going to spend here with me is going to be about how it's not done in some different databases. So I just hope that you are in the right room, you know. You can still leave, I don't blame you. This is how it's done for MySQL. It's just, and I'm not even like trying to hype up some kind of story, you know. This is from the official documentation. It's kind of small, but it's kind of, you know, claiming the same. If you want to copy the database, you just have to dump it and import it again. In a way, it just doesn't really seem to be any problem for like a small databases, you know, something reasonable. And we kind of all know that it's not going to be what I'm going to talk about, you know. It sucks. And it takes hours, it takes additional resources, you know, you just have to get the data from somewhere, put it on something else, and just, you know, putting them back in. That's the problem. Who am I? I kind of skipped that part. So I'm basically middle manager. I just lead an SRE team. It's an SRE because SRE is kind of trendy these days, but I hope I'm going to change the name pretty soon, you know, since we were before that like DevOps engineers, infrastructure engineers, and still kind of doing the same thing. So that's what we are doing now. We maintain and focus on automation for the Chipmunk infrastructure, which, even though Chipmunk celebrated like 10 years 2 years ago, it is kind of obsolete in plenty of things. So that's why this talk, and that's why also MySQL, Argo CD, and all of that things around it. So why dumping and importing? Why are we actually like talking about this issue in the first place? So there is this thing called environments. They are specifically, explicitly mentioned in GitLab CI. That's a thing. You can deploy them. If you have the infrastructure around it, you can provide it to your developers. And we did, you know, and it turned out to be like a great thing in 2019, where everybody can just click on a button and have their environment ready, you know. It turned out that everybody can be, you know, testing on almost a full production setup, you know, having all those backends, all the services, even like third-party integrations. And it actually means that data have to be up to date, obviously, you know. So in the end, if they actually click on the button, they have the environment looking exactly as the application running in production. You know, This is like a dev staging, but the same thing could be deployed for any merge request they have. This is the workflow doing the thing. I was kind of hoping that you can actually see it all, and I tried my best to fit it onto the slide. But as usual, it's not that simple. I got a feeling that everyone who's ever working on any workflow has a similar issue with that. So original workflow, only 55 jobs, 200 megabytes of a snapshot. So it's obvious that you are not really getting full production, but at least you are getting something you can work with. It took like 5 minutes to run it all, so it's kind of reasonable, you know. It's like a coffee break or something. If nothing is going to fail, you'll get your environment in like reasonable time. So people are just clicking the button, and behind the scene, the snapshot is downloaded. There is this set command adjusting the timestamps, so the snapshot is pushed into the current, day or something workable with, and that's done. Again, 200 megabytes. Even that took like 5 minutes. Each of that environment is then represented as a Kubernetes namespace and so on, other stuff, happy stuff related to it. And I have to say, at the beginning, seems like a good idea. Nowadays, 10 years later, like 10 to 20% of capacity of my team is purely dedicated to keep this alive. So, just saying. And then we have demo environments, and everything changes from like one perspective to the other. Previously, you had developers, running the environment, being happy about it, developing on it, and if they have any issues, they generally can read log messages, and with introduction of Claude, they can like help you out debug the issue. They are just not asking about the stuff which is obvious to you. But then you have salespeople, happiness engineers, all of that guys who actually want to show something to the possible, customers, for us merchants. And they also would like to have something else in production because they do not want to introduce customers right in the production before they know that they are actually committed to be with us. So that's why we have demo environments, which in a way sounds like something which is not really production related. So it was my first on-call in Chipmunk where I totally ignored demo issues because for me it was just yet another environment. And I was like reminded that it's not really true. So it's actually very production-like, and the input from user is hard to work with, let's put it this way. And what are you actually dealing with? Like, what is the database behind all of this stuff, behind the application? And we all actually understand in a second that it's just old, It's like a huge monolith. There are tables like orders with S in the end. All of them, all of the orders coming through Chipmunk, they are still there. Lock. And that's not like a lock of application, which is nice. It's just the audit lock of the actions of the developers, which makes sense. Fulfillment, there's like a whole process of logistics, If you are not familiar with the logistics domain, that's like everything happening from accepting the package, putting it into the warehouse, and pushing it somewhere else, and so on. We have actually like a table called event because somebody read something about event streams. So we have like one functionality dedicated just for that. The guy who actually read the article already left, so it's not actually developed anymore. But it's still there. Yeah, and so on. So in practice, it's just big. And it's like gigabytes of data just for the demo. So instead of like 200 megabytes being pushed here and there, you are getting at least 20 being downloaded, adjusted by set, and pushed back into the database. And also, you still have to do some kind of operation with the timestamps, right? You just can't push the snapshot back into the database and just pretend that it's in the past and it's all right. Especially for the demo environments, because you would like to show the customers that their packages are being delivered on time. So we also have to fake the dates. So every problem gets a reasonable number of infeasible solutions. None of them is optimal, that's what we know. And one is feasible, like doable and stuff. And of course, you can always buy the power, like buy it from AWS, load the data from S3, use point-in-time recovery, which kind of makes sense if you want to roll back to some specific time and just use it again and again, or just clone the whole cluster. And we explored those solutions. For S3, it's pretty easy. AWS actually advertised this functionality as this. You can use the data, being directly load to RDS. It's pretty fast, but it really wasn't for our use case anyway. So that was like thing we haven't really did. There's point-in-time recovery, which makes sense. Every morning the demo is being refreshed to the previous state. So just click on, please restore it to the way it was. We found out that it's kind of expensive for us because we are keeping really long bin log just to enable this functionality. So we kind of compromise, and instead of just relying on the bin log, we are copying the whole Aurora every morning, which is in the end a tiny bit faster. So that's the winner, and we'll still have to deal with the timestamps because since we are making a new copy of the database every morning, we have to adjust the timestamps afterwards. Increase of the cost by 100% because you just have to deploy a new database for the demo, which then had to be explained to the procurement and people making budget. So that wasn't really like that easy. But still, it's kind of easier to explain the additional cost to the people who are selling something to merchants rather than, saying that you'll have to get some additional expense of the platform about the stuff people do not really understand in the first place. So that's why we are actually reaching to Argo and the Argo ecosystem altogether with all the stuff related to it. We started using it pretty soon from the introduction. So that's why we kind of have it, and I kind of wanted to put into the context, like how old is the stuff we are talking about. So Kubernetes 2014, right? It's not new, right? Like even Argo 2017 and all that stuff around it, it's crazy. For me, something which kind of nice was that GitLab CI is 2012, well before, well, not well, but 2 years before Kubernetes. So we are still using it. We did try some alternative, but in the end, we still stick with YAMLs and all that stuff, which was really familiar to the team and could be worked on. So a few words about the ecosystem altogether. It's kind of small again. I'm sorry about it. But you have this Argo CD, which is continuous delivery part. And from the perspective of my team, delivering something as a platform to the developers, the biggest value in this that we can actually show everything to the developers and they actually know what's happening. Instead of like listing lines, going through control plane, checking the stuff in the console, they can see everything. There are no questions. It's just bubbles going here and there. The same actually is could be said about Argo workflows, which by the name suggesting is just workflows done in Argo, which are nice, fairly observable. Could be sometimes hard to manage, but it is what it is. What we are actually struggling with is Argo events, which is nice. It's like an interface for you to the whole Argo ecosystem. It has all these sensors which could be used for webhooks, pops up, and all of that stuff. But in the end, we just use calendar event, crons, and that's it. But even such a small set of services actually requires another Argo platform thingy. So that's the way it is. So what was the solution in the end? Sorry. So instead of using one command from PostgreSQL, we just had to create a workflow which does the discovery of the cluster we would like to clone for the demo. We would need to wake up the demo base instance, and that's just because we would not like to have running RDS and just costing us additional money. We need to shift the timestamps, which in the end proved to be the hardest problem out of them all. We then need to cut over from the old demo to the new demo, wipe the ephemerals, those are like Redis, rabbits, all of the related services, and then just some redeploys and exit handler with emitting some traces. And again, I try to kind of show you, I would like to show you the whole workflow, you know the drill from previous. I wanted to do something better this time. So it's not like, at 45 degrees angle. So we'll have the chance to see it all. Instead of having 50 jobs, now it's 538 jobs, 14 steps, but 20 gigabytes of data being pushed from the previous database to the new database every morning. 1 hour and 10 minutes of runtime. Amazing. Here is the workflow. This is the part which is cut. I kind of wanted to, fit it all. So it's here. And this is actually the most important part. This is the adjustments of timestamps. Each table has to be adjusted. It had to be done in some way that the database wouldn't broke under the load and so on. So this is the representation in Argo. One tiny job at the end. That's just putting the traces into the data doc, for us for future reference to have some kind of monitoring. How to write it? I think this is like the most reasonable part. You can learn something, or I don't know. Depends on your know-how. So we mainly rely on JSONet. For some reason, it was close enough for us to understand as in JSON and also as in YAML. We didn't have to study a whole new language, which tends to take a few days, even though you can wipe code it these days, except you wouldn't understand because it's wipe code. No, never mind. So everything is just written in JSONet. We rely on the libraries. There's this Kubernetes libsonet library, which you can just import into the files. And if you introduce this JB as an JSONet bundler, your code could be just looking like this. Just import the library, and the whole deployment could be just 3 lines. Fairly, understandable code. I don't know, depends on your liking. Thing is that you just don't have to write deployments, all that stuff again and again and again. And the only thing you have to do with regards to Argo CD to deploy that stuff is to implement or just deploy it config management plugin, which actually says to Argo CD hey, in case there's this JSON file JSON, it might be a good idea to initiate with JSON bundler, install all the libraries first, and then you'll be able to render all the YAMLs, all the manifest, which could be used in your Kubernetes cluster. So that's kind of nice. It's fairly usable. It helps us to keep the code clear. So that's one of the suggestions. And this is the slide, addressing that huge slide of the jobs. I showed previously. This is how we are actually adjusting the timestamps. So basically, it's just a normal shell script. It could be something else, of course, but it turns out that people actually are able to read really small shell scripts. So these are really small, and the only thing they do is just just read the database, get the columns which have timestamps, check the timestamps, and push them into the different date. And they do it in a batch of 16. Because it turned out that if you are trying to adjust out more than 500 tables at the same time, database tend to crash. So 16 was a number which was doable for our setup. So that's that parallelism part at the step block of that YAML above that. The thing is that once the workflow is rendered, just because of these 500 tables we need to adjust, it actually generates 42,000 lines of YAML, which could be also read from Argo workflows itself. But if you are not AI, you just avoid doing that altogether. This is one hint how you can actually write it. Promote clone libsonet is actually the workflow itself. It's just, again, libsonet with some steps which are taken, the time in like parallel and sequence and so on. And then like a lot of small scripts which are really easy to use and kind of debug separately. Yeah, discovery is the largest one, and everything else is up to like 50 lines of code, which is still something you can test. You don't need to really worry about it, and you can like test it separately from everything else altogether. So what is the base? This is like the explanation of the previous. I said that discovery is actually the longest shell script there it is. 184 lines, and what it actually does. You just have to know what's the base database in the first place. So it turned out that people know how to label, and in AWS you can use tags. So if you tag something correctly, it's kind of easy to find it, even like for the script. So the base database here is mentioned in the usage. So if the usage for the database is base DB template, is going to be used as a template for the other clones for the demo environments and so on. There are some other tags which are marked up there. One of them is actually showing the create timestamp, so at what date the demo base is actually currently at. So you can like move the timestamps into the future. Based on that tag in the specification of the database. One other kind of funny one, the clone plays into the target group one. It's just a small lambda which checks the RDS endpoint and puts it to the correct load balancer or behind the correct load balancer. I have a few words about it afterwards. So basically, you can just switch the demo database based on the tag, and once the workflow is done, it's going to be considered as a new clone. And again, as I was saying about those tags, like if you miss something in the cloud, you can always write some Lambda or cloud function about it. And I showed the one about putting something behind a load balancer, and there has to be another one. And this is kind of funny problem. You can turn off database in AWS. That's doable. You can do it. But AWS is going to miss a lot of money because of your decision. They are going to charge you for the storage, of course. But in 7 days, they will turn the database on again. Don't know why 7 days. Maybe some American inspiration in some Catholic literature. But it is what it is. So there has to be something stopping proactively the database every time it's going to be turned on. So again, if you don't have some functionality in the cloud, just write a Lambda about it, and this Lambda just goes around and just stops the database if it's supposed to be stopped, which is kind of crazy if you do not know this setup and just go start the database, and after like a minute or two, it's going to be stopped again, and so on, because there's this tag and magic regarding that. This is the explanation about the load balancing and so on, which is kind of nice, but I would still like to have the native functionality provided by AWS itself, but it is what it is. What it actually does is just checking the tag, and if there is going to be a new instance saying hey, put this instance behind a load balancer, it will do it for you. And it actually enables us to do some sweet stuff regarding a cutover. We can be deploying new demo database. It could take hours. Nobody would notice because the cutover to the new database will take place once everything is done. So, summary. I think still on time. It turned out that developers are able to use workflows. They call it DAGs, and okay. So they were able to debug it with us, which is great because then we have their involvement, they buy in and so on. Everyone can read shell scripts which are reasonably sized, even AI. So that was really helpful. The time machine actually turned out to be miserable in sense of taking the lot of workload, a lot of time. but it has to happen because other than that, you just don't have really like any reasonable solution. We are looking into some, procedures which could be run in MySQL. Those are really hard to debug. The support regarding that is just something really old. And after like doing some benchmarks, it turned out it's still easier to run the jobs aside, 500 of them, and adjust the timestamps separately from the database. It's fairly observable. If you are familiar with these 3 tags, you can like create your demos, run the workflows. It's nice. And the previous statement, which I think forgot to mention in the first place, like, can we do it under an hour? Well, no, but since the cutover to the new database is done separately on the demo environment itself, nobody actually notices that something is happening. So it's like new demo database is created, everything is done, and then it switch over, and it can take an hour, 8 hours. It's still all right. So all in all, fun project. Enjoyed it all. AI had fun. It haven't really cost that much tokens. I'm not even paying for them, so that's all right. What was really nice, the developers actually understood it as well as we did, which is great, especially like, if somebody from, managers tends to do this, like, hey, you have to cooperate with developers. You are just not the platform. You have to deliver some value and so on. So this project actually fulfilled it as well, because even salespeople can use it afterwards. So that was nice. No MySQL dump. So that was actually pretty nice. I know that there are some alternatives like MySQL, SH, and so on, but they tend to be also really unstable with large set of data and so on. Yeah, so that's it. Cool, I'm on time. It was like a fun little project. I was really happy to share with you guys. Not that many people actually are asleep at the moment. I take it as a compliment. And enjoy your day if you have any questions. Right?
Yeah, thank you. Thank you so much, Martina. Yeah, I think the Slido is live, and it's also live on my machine. So with that, I will be very happy to review the questions. Any questions from the audience for the start? All right. Check it out. Slido is open up right there. Yes, sure. Yeah, I will bring you the mic.
Thank you. Can you hear me? Yeah. I wanted to double check or clarify the demo environment. Was single one, or do you had more of them? Because that was kind of the point you mentioned, that you don't want to run infinite number of demos for each customer maybe. So I want to double check that.
Yeah, that's a great question. The thing is that sales would like to have new demo for each of the merchants, just to see, just to have something separate for them. And we manage that argument in a way that it's going to be really expensive. But in the end, we still end up with like having 4 demo environments for different purposes. So again, since dev environments tend to be really small and developers are pretty okay with running stuff on spot instances and so on, that's all right. But for like demos, it tends to be expensive just because everything has to be like almost production-like, very stable and so on. So it's still around that number of 4, but hopefully it's going to be much less in the future, just because that's where I kind of tried to mention at the beginning. The expectations of developers from anything is that, hey, it can fail. but sales and people interacting with the application, they do expect really high availability, and at the end, it just shows up to be really expensive. So it's like 4 of them at the moment, and hopefully the number is not going to be bigger. Yeah, thanks.
Okay, thank you. Thank you.
Thank you so much. There's one question from the Slido, so let me read it out loud. When you showed the 500 job pipeline, how often is the pipeline actually successful?
Oh, that's every morning. It's still the thing is that we struggled a lot. That was our limit. I was kind of like pushed into it. In the end, everything you run depends. But for us, everything you run in the workflow materialize as one job, one pod running in Kubernetes. So longer you run your pod, higher the chance is that it's going to be evicted, something wrong is going to happen to it. So if you give yourself like a hard limit of 10 minutes, put there some pod disruption, configuration, set up the annotation correctly, for toleration and stuff, like 10 minutes of the runtime is still kind of reasonable. So it does finish correctly every morning for, I don't know how long, like a quarter of the year already. And of course, there are some things which fell from time to time. The thing is that if adjustment of the timestamp fail, you can just retry it. It's still one table, and it's not going to go anywhere if you have your transaction set correctly and so on. So it's fairly reliable.
Fair enough. Thanks. Yeah, let's take this question.
My question is regarding Postgres. On the first slide, you said that Postgres can clone a database in one line, in 2 lines in a few seconds. But I doubt that it is possible for your use case because, as I understood, this is possible only if in a single server, Postgres server, and if you usually have production environment, you have demo environment, you have sales environment, and they have distinct databases, MySQL in your cases. And in Postgres, this means that this command for the first slide will not work, actually, because it needs to make a copy of database between different servers, not in a single server.
I got it. And that's the correct way of to think about it. But maybe I didn't understand correctly. For us, we try to keep everything in like single instance for a really long time, especially for the MySQL, because it's still MySQL. Once you actually put it somewhere else, you just have to pay the tax of putting the data out and in and so on. So like for most of the apps running on that huge monolithic backend I was explaining at the beginning, the database or the instance is just one. So that's the thing. And the point is that the PostgreSQL command wouldn't work in the first place anyway because it's still the same instance. The multiple instance setup is just a result of the issue we had, because like cloning the whole SSD drive tend to be much faster than just doing MySQL dump and then importing it. So that was kind of the point. But yeah, good note, thanks.
Okay, thank you. I know there's one kind of related question in the Slido. Do you plan to migrate to Postgres?
Yeah, I would love that. The thing is that for some reason, I'm not the only one who's making the decision. And again, the problem is that huge monolith. Like every time somebody tries to cut some functionalities out and creating new service out of it, it's just taken, incredible large time. And that's the point where you actually need some manager who will just go to the people and explain to them, hey, this is needed. We have to do it in a different way. And I guess like every last one of us have the experience like this. Explaining somebody from sales, for example, that they need to wait for like a half a year because we need to do some rework and restructuring something, that just sucks.
Got it. Thank you. Is the question still valid? Sure. So go ahead.
Thank you for sharing information. It's from inside. So the question is, what do you using for the managed cloud resources for all of this running of the workflows? I mean, engines like possible Crossplane or whatever else. Terraform, what are you using?
Oh, yeah.
I mean, anyway, you have to adjust the resources dynamically, not just keeping off all of this always running.
Yeah, the basic setup was in Terraform, but since you are like copy-pasting the database every morning, we solely rely on that workflow to not get crazy. Because you would then have to still go back and adjust the Terraform state, but it turned out that it's not really like needed in that sense. You know, like everything you change in Terraform tend to get changed back by those Lambda functions, and that's something which is fairly misleading. You know, like those labels and tags, we tend to think about it as an annotation in Kubernetes. You know, you annotate something, and it's going to somehow get some different behavior, fulfilling your desired wish based on that annotation. You know, like I don't know, like some setting in ingress and so on. The same behavior could be done in resources in AWS, even though it's not like visible on the first look. You just have to go into the tags. So managing that is not easy. That was my biggest worry. If I'm going to fail something, just forget about it. For like 10 days, I'll have 10 same demo databases costing us fortune. So it turned out that after some like rigorous testing, this could be avoided. But yeah, I kind of got the picture. Like having the state at the moment is not really that easy, since you always have to check what happened. You know. check. Jeden.
Raz, dva, tři. No, teď už funguje, já nevím. Hello, everyone. I think it's time to start. I would like to welcome with a big applause Andrei from Enix, who will speak about treating Kubernetes as a Linux distro and some APT-like magic. So and how they solve the egg versus chicken problem. So handing over to you, Andrei.
Thank you. And it doesn't work. All right. So a few words about myself. I'm CEO and founder of Enix. We develop Cozy Stack. This is open source solution which allows you to automate data centers and solve various stuff around Kubernetes. You can know me from various communities, especially Cozy Stack, Linstore, Kubevirt, Talos Linux, Cilium, and so on. Talking about Cozy Stack is a platform which allows you to order managed services like you have in AWS, but it allows you to install it fully on self-hosted environment. The platform itself is fully based on Kubernetes, and we use open source operators and solutions from CNCF, Cozy Stack, also CNCF project. And today I'll be speaking about how we organized our packaging system in Cozy Stack. This is actually a dashboard where user can click and install any service they want to. But before we make this available, you need to prepare a stable base for your applications because all of them need, they have a need in storage, networking, virtualization, and also what does it mean, managed service? It doesn't mean that you just deploy a pod and forget about it. To make services truly managed, you need to ensure that all the day-to operations are working fine, like backups, monitoring, failover, and so on. For this, you need to have a stable base. Of course, we chosen Kubernetes. And before you start using Kubernetes, you can't use just pure Kubernetes. You also need a ton of components, such as storage, networking, virtualization, and monitoring. They are base for all the managed service we run in our platform. In fact, we just built such a platform stack, which includes operating system management, then specific components which solve storage, networking, virtualization. We also made them replaceable. Then set of operators, cluster API, monitoring system, and only on a final level, we provide user API to let them define their own applications and let their users to order managed services. The main core value of Cozy Stack is that we consist of many open source components and we just provide such a glue. We can make sure that all of these components working together well. So we continuously contribute to upstream projects. If we change anything, we rather go to upstream project and contribute there instead of implementing it in tree. And we make this stack reusable across various environments. It could be a cloud environment or your own bare metal environment. Bare metal also very different. So that kind of challengeable. Is that a distribution? That looks like we solve the same thing like Linux distributions were solving for 30 years already. Just use Kubernetes as a base. In fact, it is, and we organized our development quite the similar way. So we have monorepo pattern, where we include upstream charts, we slightly modify them. Sometimes we can also update the images, so we hold the patches in the same monorepo. In fact, we just take this monorepo and deliver all the components all together. Like new version of our platform is just a single version of this single tag of this monorepo. Inside of this monorepo, we have few group of packages. First are system singletons. You can see such components like Cilium, cert manager, I know, ClickHouse operator, and things like so. So the components which get installed in a system at once. on a system level. Those apps are also Helm charts. They define user API to order the specific services. For example, user wants Postgres, Kafka. They have specific YAML to install specific instance in their namespace. We also have extra, it's slightly tricky tenant modules. It's tenant singleton charts, usually dependencies for make other components working. For example, if your user wants to deploy S3 bucket, they need to have a storage deployed in their tenant namespace. If they requesting Kubernetes cluster, they need a etcd running, which stores the data for this Kubernetes cluster. I usually tell charts are packages. In fact, Helm is a package manager, so why not? You can take a look at various distributions, Linux distributions and FreeBSD. They have quite similar organization of the packages. Especially I really like Alpine Linux because it has exactly the same structure we have chosen. But Gentoo, Nix, and FreeBSD, they have quite similar organization. For the distribution, we use FluxCD. FluxCD is a main core engine which delivers all the Helm charts in our platform. They could be system or user charts. In fact, the all is driven on, by FluxCD, but we use it in different way. Originally, you take FluxCD and connect it to some external Git repository. In our case, we do that different way. We actually perform an artifact, and from this artifact, we deliver all the charts. This artifact contains actually all the charts, and we cut only this artifact. That means like specific platform version. For example, we have this Git with this structure, apps, extra system. We pack it into Docker image, then we install it into specific Kubernetes cluster, and then Flux can install specific Helm releases from this OCI image. And also we have another level of abstraction, which represents the same FluxCD Helm releases as normal Kubernetes kinds with no reconciliation loop. So it's built on top of aggregation API. It just represents, instead of Helm chart, you see normal kind, bucket, kind, Kubernetes, kind, Postgres, and so on. But let's come back to the FluxCD. Where is this configuration stored? We have additional platform chart which holds all the configuration should be installed in a system. In fact, we have also core, platform core components, and this platform chart. It contains all the Helm releases. This is like Matryoshka, which contains many Helm release configurations. And we also have, so we run it, originally we were running it as a HTTP server in our platform and let FluxCD read the data from it, like charts data, and deploy into the same cluster. That was working fine. For the configuration options, because every customer needs different options to be installed, maybe some components, enable it or disable it, we introduced bundle system. For example, bundle 1 includes the first set of the components, bundle 2 includes the second set of the components. And they can also have different configuration because it's just up, pattern. Actually, you can choose the bundle, just provision the specific option for the platform chart, and then it will deliver the rest of the Helm charts into the platform. In fact, everything is a Helm chart, even this. That allows us to customize it very simple, and that drives us to the next part of the talk, is how to make the development convenient. The main trouble when you're developing stateful services, it's quite difficult to test them. Usual flow that you make some change in a code base, you push it to CI, you wait for building, you wait for end-to-end tests finish, then you see some error, and then you repeat it again. So we wanted to completely get rid of this situation, And we just invented Cozy HR project and Cozy Flow, developing flow. The idea is simple, that you can just take the source code of some Helm chart, you can simply rebuild it, somehow change, and directly apply to the cluster with the same values stored in the cluster. For this, we invented this Cozy HR. It includes few options like show, diff, apply. Diff will actually show you what is changed between your live state and your local state in a repository. In Cozy Stack, we cover everything with a makefile, so every package includes the makefile. It also has a few additional targets like make update, which automatically downloads upstream chart. Yeah, we also vendor all the upstream charts in our repository in order to make some changes. For example, we can simply apply some patches or modify it somehow. Also, we have make image, which actually builds the local Docker file and records it into result values file. So in fact, we have this artifact which you can simply apply, and you can see how it's changed and test the behavior even before you push it into your CI system. The second topic is delivery. By making this platform distribution, we want to reach simple installation. We want to let our platform manage the state of whole Kubernetes, including CNI, kubeproxy, and so on. But the thing is, you can't simply install Cilium via Flux without Cilium and actually kubeproxy. That's actually chicken and egg problem. We were solving it different ways. The first option was to install Cilium manually, then hand over the management of this Cilium Helm chart to the FluxCD. That was working for some time. Actually, one small script of 100 lines of code was responsible for this. But we decided to solve this. It wasn't working very well. We wanted to have more native option to do that. And we just found Flux all-in-one project. It's Stefan's project. Stefan is a core maintainer of FluxCD. And probably for his home lab purposes, he built this option also because he wanted to install CNI before the Flux. So we started using it, but also during our existing system with internal HTTP server, it was quite challenging to solve that stuff. Because if you install FluxCD in a cluster, if you have this HTTP server running, but you have no kubeproxy and you have no CNI, you need somehow solve the case how Flux will actually connect to the, this HTTP server. There were some fancy options like to place them into the same node, but in this case, you need to jungling with these placement options. You can create a sidecar, but in this case, during updating the asset pods container, it will also restart the whole FluxCD. And we found more fancy solution. That's actually reusing Kubernetes API server in wrong configuration, I would say. If you know, Kube API allows you to run port forward, but also it exposes it as single HTTP endpoint. So if you're accessing Kubernetes API server under this path, like /port forward with correct certificate, which allows you to do that, you can actually download Helm charts directly from Kubernetes API because it will proxy to the pod which holding those Helm charts. That was a nice solution, but quite tricky. So we decided to go even more further to solve that complete and correct way. The correct way is to store this OC artifact and don't run any HTTP server in our platform. But let FluxCD download the artifacts from the external Docker registry with no need to have HTTP server. Actually, the idea is to pack everything into OCI image and just let Flux download it and install it with no need of HTTP server. But there is another problem, that Flux does not support OCI backed multi-chart Helm repositories. Even Helm does not support them fully. When Helm introduced their OCI support, they changed also behavior from the repositories to single packaged charts. So we can't just create a single image with some version, which is single artifact and single point of truth for our platform. To migrate this new scheme, we would need to pack any chart for any component into specific artifact. And these are actually multiple artifacts and no single point of truth. We didn't want to do this, and we start looking how can we actually put all the Helm charts into single image and download and install them from it. And then I had a conversation last KubeCon with Stefan. He just said that we're trying to solve that wrong way, and there is already another solution which allows you to solve that. It's called FluxCD Source Watcher. That's actually new FluxCD controller, which allows you to compose and decompose artifacts the way you want to write in runtime. It's actually designed to work with OCI artifacts the way you want to. It's not tied only to Helm. You can use any FluxCD backend because all of these Flux controllers, they're replaceable and you can work with them the way you want to. In FluxCD, they have these two commands, so you can take some directory and just push it into OCI image, or you can download OCI image and extract. That works really fast, way more faster than you just building another Docker file, like just a seconds, and all your directory with Helm charts already in OCI, and you have a tag which you can use as single point of truth. In fact, it integrates with the same FluxCD entities. So the source controller is the first. You have kind Git repository, or you have kind OCI repository. You can even use kind Helm repository. Then you can create kind artifact generator. And out of this artifact generator, you got a few external artifacts generated. And then you can use standard FluxCD controllers like Helm controller, and you just specify that you have to install the Helm chart from the specific external artifact. That works pretty nice. Actually, with this new artifact generator API, you can build the charts you want to. You can pack dependencies right in runtime. You can construct the charts on the fly from the source code, from the different sources. The part chart can be stored in Git, another part in OCI, so you can do whatever you want. But the format is quite complex for the human. You can do mistake quite easily. So we decided, so this kind of low-level format, and we need to create an API on top of this. And also we got another business problem. At the time we were solving this problem, we got another one, that we got another client who wanted completely different platform stack, but still reuse some components. And that's the thing, how to make the things reusable. So for now, we have few different type of clients. We have ISPs, enterprises, banks, and hosting companies. All of them need the same solution, but slightly different. They need the same things as others, but something new. And options are not enough for them. The bundles are not enough. They need the more better level of the customization. And we, in fact, want to build a product, not 50 different forks, which are difficult to maintain. That's the main goal of the business, that you do the same thing for multiple people and sell it for the same price. So in fact, we just want to have a single product, and we want to reuse the things. And at this time we just get an idea that we need a package manager, just like in any ordinary Linux distribution. Yeah, I got inspired by Alpine Linux because they got really simple interface of installing and removing packages. And we decided to repeat it, but in the Kubernetes level. Platform chart now includes not Helm releases, but package sources. Package source is a new CRD in our case, which actually results into artifact generator, which then results into external artifact. And when user wants to install, so they already have information, kget package source, they see all the packages available to install. And if they want to install something, they need to create kind package, which has the same name like package source. In our case, both APIs are cluster-wide. And package already creates a Helm release, which then use this external artifact. The logic looks like ordinary Linux distribution. When you connect apt sources, you do apt cache update, it downloads the source of all the packages to be installed, and then you run apt install and you install specific packages from the source you have already, the metadata you have in your local PC. So the package source looks like this. We have also a few differences to ordinary Linux distributions. Just because of the Kubernetes specific, we introduced variants. So every package can include variant. For example, our networking package includes options to install Cilium, Cilium with Kubovian, or Cilium with Kilo. Every variant is actually just values files stored in the same package in our Git repository. And we have also a package which actually user intention to install specific package. In here, they have to specify specific variant, and they also have opportunity to override Helm values for all the components. Yeah, in our case, package can include multiple Helm releases. That might be really useful if you install, for example, cert manager, CRDs, and cert manager. But in fact, this is single package, and we still need to solve dependencies. And the package manager is the thing which actually solves the dependencies. In our case, we have two levels of dependencies. The packages can depend on different packages. That works even if you define packages from different repositories. But we also have this inside of the package dependencies between the components. For example, cert manager CRDs should be installed before the cert manager. These entities are solved by cozy stack operator, and it's quite dumb. It doesn't solve any dependencies. It just checks if dependency installed or not. So we could compare it with DPKG, and we have user-facing tool which is called Cozy PKG. With this tool, it's just wrapper around Kubernetes interface. You can run Cozy PKG list. It will just show you all the lists of available packages with their variants. If you want to install something, you just specify Cozy PKG add and specify the package name. It will solve all the dependencies chart and provide you options to install the dependencies in specific variant. And it can also generate fancy charts, like with those dependencies. That's the same like Alpine does with their package manager. So you can see all the dependencies of the packages between each other. And we actually found this scheme quite useful. That was working fine. But what to do with our existing clients? They already have chosen this all-in-one solution. And they have already a cozy stack installed. They already using specific bundle with the components. And we don't want to break their experience because the simplicity is one of the idea of our platform. It might be quite complex to configure all of these open source components together, but we provide simple installation method, and we don't want to break it with opportunity to install all of these packages and explain to the users how it works. So we decided to still put some kind packages in our platform chart and install them when specific variant of this package have chosen. By default, we install nothing, just package sources, and let user to pick and choose specific the components they want to from the platform. But we also have predefined bundles, ISP full, generic, and hosted, so some specific bundles, predefined configuration and packages, which also includes migration scripts. So we just migrated our users to that bundles and continue working that way. In fact, we got these two options of using the platform. The first option is all-in-one distribution. It's like when you're installing Ubuntu desktop, you got a ton of the packages pre-installed. And the second option, build your own platform. It's like Debian net install, where you have minimal system, and then you just pick and install the specific components you want to. That's the thing. Let's talk a little bit about the evolution, because for now, Cozy Stack already includes many different packages. We got community contributions who continuously want to bring new functionality to Cozy Stack. And we don't want an error syndrome situation. If you know this software, there was software for building, for burning your CD-ROMs, but it started growing by continuously adding new functionality like video player, music player, and so on. So in fact, this project just get dead, and we don't get to get into this situation. Conclusion, we just checked what the other projects, how they solved that. And we found that they actually just decomposed the project to different zones of responsibility. And we invented pluggable repositories. That's the same idea, like every vendor can take a Git, they can prepare the same structure, prepare OCI image, and provide simple manifest to install it. In fact, the user of Cozy Stack, they can just take this manifest, install it in their cluster, and they will see the list of available packages. From my point of view, that should work very fine when we become even more popular. Some vendors will start preparing their own managed repositories for Cozy Stack. That looks like our or Ubuntu PPA. I think that will work better in a while. And the next steps is to decompose the components from in-tree and start developing them as out-of-tree repository. You can see all of these solutions, they started and they go the same way. First, they develop the components in tree. Like, remember, Kubernetes, they includes Azure, AWS, bindings in the code from the beginning. Then they invented interface, like CSI, CNI, to let users provision external implementations and use it through this interface. And then they moved and they already deprecated all of these CSI, CNI drivers. They work only through those interfaces. In fact, we want to do the same in Cozy Stack. So Cozy Stack will remain just a framework for delivering such packages. And users, including us, like core maintainers of Cozy Stack, will provision our repositories. But in fact, you don't require to install our own packages because any Linux distribution or Kubernetes distribution, from my point of view, it's a package manager first. So you can use the same methodics to deliver your software or to make connectable repositories to Cozy Stack. So we can see that Kubernetes looks like a new Linux. It has the same developing path. And my idea that future is echo-driven Kubernetes distributions. So don't build platforms, build ecosystem. That's it. Few links I've mentioned in this presentation. Here is a link to instruction how this works, FluxCD source watcher, Cozy chart, that's tool which allows you to simply develop with FluxCD. It works even not with Cozy stack, it just requires you Git repository at Helm. Example of how can you build this repository and publish it to the Cozy stack. And finally, this article on Kubernetes.io, where I described how we actually build this API interface for representing Helm charts as normal Kubernetes kinds. Many thanks to my wife designer who designed this beautiful presentation. And that's it. Thank you.
Well done. Thank you so much, Andrei. Great stuff. We already have some questions coming in. You can submit your questions using Slido. So the first question is, how does your package manager deal with conflicts between packages, such as different versions of CRD in different packages, etc.?
For now, we just say that when you're developing repository, the core value of this repository to be sure that all the components in the same versions are tested and working fine. We have CI who is checking this, but we didn't solve the case when you have different packages in different repositories yet. That's a good question. I think we will solve that in a while.
Got it, got it. Yeah, let me mark it as red. Yeah, I'm approving the messages going in here. Any questions from the audience meanwhile? Yeah, go ahead.
Thank you for the presentation. And I have a question regarding the version upgrades. Usually these components are evolving and new versions appear. And how do you resolve this version upgrades problem? How customers, users can upgrade their components to new versions when new versions appear?
We don't provide any option to install specific versions of the components. So every snapshot of our repository includes hard-coded versions. If you need to provide specific versions, you can provide them in values file. But in this case, you have commitment that if you provide this choice to the user, it will not break anything. So you need to have a test that matrix tests that they deploy some previous version or existing one, and you actually guarantee that it is working. And there is also another question about how we do the migrations. In our case, migrations are run a separate job of this platform chart. Before all the new Helm releases get installed, you have the opportunity to run shell script, which will do whatever you want. For example, remove CRDs or do some changes in the platform.
Thank you. The next question is, when would I use FluxCD solution instead of Argo CD?
I have really big article about this. I really love two solutions. I like Argo CD, their interface. In case if you want to provide this interface to your developers, actually you can just let them use Argo CD, but not using having no access to Kubernetes. And they'll be happy just because they can see the state of every pod in development. So that works just fine. I still think that FluxCD is more Kubernetes native. They have Kubernetes RBAC, and Flux is better for building distributions.
Got it. Thank you. The next question is from not Sam Altman. Any way to provide channels, latest beta LTS?
Yeah, that might be an option, and that could be really simply integrated. In fact, when you're installing the basic platform of from the Flux, you can pin to specific versions. So you can specify literally star for upgrading patch releases, but not upgrading the change releases. And we are thinking about reusing this strategy to enable automatic updates for the users of our platform.
All right, thank you. There's right now no more questions from Slido. One last question from the audience. We have space for one last question. All right. If not, thank once again, Andrei. Big applause for Andrei.
Thank you.
switch to English, maybe it's yeah. So how was that with this? Float code. Oh yeah. Okay.
Because what design not like a design.
Yeah.
It was really fast.
Like they told me, so they used to design their presentations. They submitted like all the breakdowns on the stuff, and it did nice overall. But the biggest thing is like changing something. Because like it was then reviewing something that were not asked. So that's what they hated. So the skill for code to generate as HTML was the so that's what yeah. So that's the more that you're really listening. Yeah, exactly. Exactly.
Nice t-shirt.
Yeah, I crafted my company's purple one. Then switch to this purple one.
This is PHP application. I don't remember. They have this pushka. Personal PHP application. Pushka. Kubernetes for the kids. They have this book. You didn't know?
I didn't know. I'm an educator, so like I don't know like these key stuff for the kids.
Check it out. It's cool. Like. I'm not sure how it is in English. In Russian, it's plushka. Plushka. Pardon. Pushka. Pushka. It's also. They have really cool books.
Не знаю. Я очень бы хотела сходить в комнату маленьких детей.
Давай меня оставляй.
Привет. Всех рада видеть.
Yeah, oh, okay, so it's like translated to multiple languages, so like...
Yeah. Okay. How is it in English?
Yes.
Что, плохо?
Нормальный дизайнер. Делают переходные части.
Вот кто-то херово генерировал.
Да, он делал очень плохо. Я поставила... Короче, я это правила. Чтобы она выглядела вот так. Это очень странный момент, потому что... Смотри, все остальные классические Да, и я вообще удивлена, сколько иллюстраций отсюда выйти. Он так подсвечивал, там у нас перемирочные слайды, я делал уже часами. Блин, обидно.
А что, плохо смотрелось?
Ну, я тебе покажу слайды.
Can you read this? We don't see anything. Oh, never mind. You can read that though. We can read that. Pass the first test. We're going to assume you can read this. This will be ready. This is all fine.
Yeah, let me see. You feel that it's smaller, or like it's not readable enough, or? All right. Yes. Yeah. Okay. It's up. Brilliant. Brilliant. So. Come on. Oh, yes. This one is yours. Yes. Brilliant. All right. Yeah. Hello, everyone. Welcome to our next talk. We've got Brian Exelbierd joining us with his talk about the OS layer your platform ignores, and he will speak about taking care of Kubernetes nodes, file system matching, and like a lot of other cool Kubernetes stuff. So please welcome with a big applause, Brian.
Thank you very much. As I was introduced, I'm Brian Exelbierd. I work for Microsoft, and I'm telling you this for a couple reasons. The first is I work in Azure on upstream and community Linux, so I'm not a Kubernetes person. So any silliness that I do in Kubernetes today is my fault, not the fault of any tool that I'm going to be using. I'm using a couple of tools in this demo. One of them is going to be Azure. Doesn't matter that it's Azure. I happen to work for Microsoft. Very easy to get Azure access. But this works in any cloud provider you can think of. It works on any hypervisor you can think of. It works on this 2017 laptop. So there's no vendor there. The other thing that I'm going to be using today is another incubating project in CNCF called Headlamp as a graphical interface to Kubernetes, which I'm going to be running as part of my demo because I don't want to learn any commands. Let's get started. The slides are at this QR code if you need them. So this is the question that I want you to think about. You've got a lot of nodes. Can you prove they're all identical? Many people will think they can, but there's a lot of edge cases that crop up that cause us to not actually be able to answer this question accurately. And you can't generally do this below the, yeah, it'll run all my jobs level well. And there's a lot of reasons for that. A lot of it is because we tend to use traditional Linux systems underneath our Kubernetes nodes, and they are mutable systems, and mutable systems have the beautiful property of mutating, which means that old nodes will differ from new nodes. And there will be a problem, and an SRE will SSH in, and they will do something. And maybe they put in a binary that didn't go through your CI, or maybe they put in additional logging flags that aren't part of the system normally. And now that node is different. It may be something simple. They might just leave a log file or a TCP dump somewhere, and now the disk space utilization on that node is different, and you're cruising towards a failure because one node is now different. And all of this divergence that I'm talking about, it's all invisible. It's not visible through version numbers. You can see the same kernel, the same OS, the same kubelet, but there's still a difference. And in order to find that difference, you typically have to do a package-level audit of the system. You might even need to do a file system-level audit of the system. And we do have drift detection in Linux. We've had it for a long time, but it's detection, it's not prevention. And these audits, they don't scale well. When you're at 100 nodes, maybe. Go higher than that, not practical. Do it continuously, also probably not practical. You're going to cut your capacity seriously. So this isn't a Kubernetes problem. I want to be very clear about that. Kubernetes is really good at managing workloads, but it is very bad at managing nodes in terms of this deep level management of nodes. And there's really not inbuilt pieces of Kubernetes that do these kinds of health checks. Sure, you can do a kubelet health check, but that's going to tell you, is the system ready? Is it ready to take workload of that type? Not, is the system the same as all of the other nodes in its class? Basically, from wherever you look, these systems tend to look identical until they explode on you. So what should we do about this? The Kubernetes security community came up with this concept of shift down. There was a white paper released last year. I strongly encourage you to read it. The shift down community said, we already have shift left. Shift left is where we take security earlier in our pipeline and we solve problems before they get to production, before they get to deployment. We inbuild those security promises and guarantees. Shift down posits that we should be taking that same concept and pushing security deeper into the platform layer. How do we make sure that the platform has the security promises and guarantees we want before deployment, before workload? Now, the folks who wrote Shift Down, they were talking about Kubernetes. I'm a Linux guy, right? I say shift all the way down. What if we could shift all the way down into the node OS? What if we could make it so that these kinds of drifts aren't just detected, but they become impossible? And this is built on good ground. Kubernetes has a long history, CNCF has a long history of doing the right work here. We've got Salsa, we've got SigStore, we have done amazing things with SBOMs and transparency. But again, all at the workload layer. Not a lot of it's hit Kubernetes at its actual deployment layer, and basically none of it has hit the OS. And a lot of the conversation is now focused on the Kubernetes layer and not the layer below it. And so I want to introduce you to Flatcar Linux. Flatcar is a CNCF project, which means it's community governed, vendor neutral. All the assets are owned by CNCF. It is a special purpose Linux operating system. All it does is run containers. It runs containers any way you want them run. It is an incubating project in CNCF, but incubation as a label here doesn't tell you a lot. It tells you a lot about CNCF and how long it's been in CNCF, but Flatcar actually has a very long history as an operating system. It started with something called CoreOS Container Linux, which took Chromium OS ideas about how to manage systems and built them into a real useful container Linux. Red Hat acquired CoreOS, that company, and they took container Linux and they mashed it up with some other stuff at Red Hat, changed the tech stack. They've gone off and done great things. But another company called Kinvolk formed, and they took that original code base, forked it, named it Flatcar, and kept it going on the original technology line and concepts. Microsoft bought that company about 6 years ago, and then we have donated the operating system into CNCF. So incubating doesn't really tell the whole story here. So Flatcar is immutable, which means that user is read-only. We also DM Verity protect it. DM Verity protection means that there's a set of hashes that walk through the entire set of blocks in the partition, and every time there's a read done, we compare that block to its hash, and we refuse to execute code that has changed. So if somebody managed to break your system, the hash would be screwed up, but also if you just get a cosmic bit flip, there's not going to be that kind of a problem either. The system's going to abort on that. It is not going to warn and then execute. Because it's immutable, there's no package manager in any traditional sense of the word. So installing things is difficult. You really can't install things. There is a process. I'm going to demo it for you. Updates are atomic, so this gets around that mutability issue because atomic updates means they are deterministic. You also have a very easy way to sanity check your nodes. Version IDs now mean something because the version ID is tied to the immutable user space. So if you compare version IDs, you can have a provable statement about these operating systems, or these nodes. Etsy is still writable. I want to disclose that. You can still get configuration drift. We are working on that. I'll tell you a little about that later. And this is, in my opinion, shift down, starting to be made foundational underneath your clusters. User space drift is not just detected here, it's just basically impossible. So I'm going to demo a couple things today. First, I want to show you what we're provisioning. This is a butane configuration. It's YAML. You transpile it into JSON because why not have two formats? And what you're going to do with this is define the contract between your workload and the operating system. Here I'm going to be using Kubernetes as my container execution. So I'm going to define that that's what I want. The project is going to deliver you an operating system that executes on that contract. So you don't configure Flatcar, you deploy Flatcar, and what you get back is the end result of your contract. So I'm going to use something like this. I've made some additions. The code will be online. Basically, I've got an SSH key. You probably wouldn't want that, but I need to SSH in, and a few other little things just to make the demo work. This is a single declarative file, though, so every system that I deploy from this declaration will look the same. They will all be identical. They will not drift. And I'm going to disclose this is the AZCLI command I'm going to run. I show it to you mostly so you can see that in user data, I'm just passing that transpiled JSON in. There's no magic here. It's not something mystical. A lot of providers can deploy against this same contract. So I'm going to start by seeing if you can read that. That is the wrong screen, but I hope you can read it. So I've got two nodes right now. I have a worker node and a control plane. This is headlamp. This is what I'd mentioned to you. I have cheated. It is running on my control plane so that when I take my workers down, it doesn't crash. But this just shows you I've got two nodes. I don't know why the memory displays like that. And let's see if we can do this. Okay. Can you read this? Good. Okay. I am a lazy demo guy, and so I'm going to start a new worker node, but I'm going to do it using a shell script that just builds with some seds the actual pieces I need to launch in Azure correctly, because otherwise I will never type this correctly. I do the same thing to build an SSH command, and I call it go, because again, I would never type all of the which key was I using in this demo environment stuff correctly. So one of the things I had said to you was that there was this magical version ID. Let's take a look at it. When I practiced, I did not practice typing in this position. Sorry. So we are running version 4593.2.0 of Flatcar. I'm told that our version numbers have to do with days from some special day. I have not bothered to look up what said special day is. I'm very sorry. But that's a version that we're running today. I told you that user was read-only. Look, I can't touch it, except I'm not root. So let's become root. Look, Ma, can't touch. It's a read-only file system. It's not giving me a permissions error. It is literally saying, you can't do this, sir. When I do a longer form of this talk, you can't remount it either. Don't worry, it really doesn't work. This is the DM Verity protection that I was talking about. This is the top hash of the hash tree that protects us. I'm actually going to copy this. Thanks to Tmux, you cannot see highlights, but trust me, I copied it. And so this is what the hash looks like right now. What I want to show you, though, is it's almost up. We have worker 2. It's up enough. It's still joining the cluster, but like the system's running, and we don't need it to be in the cluster for this yet. Congratulations. Welcome to worker 2. DM setup table. So that's our table, and we are about to see if they came out right. They did not. Uh-oh. Demo gods got me. Let's see if it came up with the wrong version on it. No. We will solve that in post. So these should have been identical, and thanks to the demo gods, they are not. But you would be able to see that the version number and the hash were tied. I'm going to have to find out why Azure chose not to do that for me this time. That's the theory. We will keep going, though. One thing that I will show you right quick, I've got a basic deployment of Nginx running, and I'm going to scale that out just so you can see that worker 2 will, in fact, pick up workload, and we're all going to pretend the hash is matched. There you go. Worker 2 is picking up some workload. So now that that live demo has failed, I will prepare you for the other two. It normally works. I am genuinely not sure why that did not come through, and I am not going to debug in the 30 minutes that I have on this stage. What I am going to say is that that was weird, but we will talk about updates instead. So the way that you upgrade FlatCar is that you have two partitions, an active partition and an inactive partition. They happen to be named user A and user B. The naming is completely arbitrary. They could have been named Petter and Petra. I discourage you from doing that. But FlatCar doesn't do package level updates. Instead, it uses these two partitions to stage new versions of the operating system. So while your node is running, on your policy, whenever you believe it's time to whatever version you choose, a new version of the operating system will be downloaded to the node. It will be written to the inactive partition and validated. At that point, only once all of those steps have completed does your running system do anything. And all it does is raise a flag that says, I'm ready to be updated. Updating is just a reboot. So in Kubernetes world, you'd want to drain, cordon, reboot, rejoin, pick up new workload. Rebooting is, again, done on your schedule. If you don't make any modifications, the system ships with a rule that says reboot as soon as something is available. You will learn this once you put in your first monitoring system. I did the hard way. There are a bunch of operators available, the FlatCar Linux update operator, curd, etc. Again, it all works with standard Kubernetes. It all updates as you're ready. And I will attempt to show you an update. So the first thing we need to do is to cordon that node. Let's use worker 1. Let's drain. We should see our workload move over. Ta-da! Okay. And now, are we back in 1? No, we are in 2. Let's go back to 1. Get my cursor back. All right, let's start by looking at our 2 update partitions. So these are our 2 partitions. As I said, they're arbitrarily named user A and user B. The highest priority partition that is successful is the one that we're running, so we happen to be on user A. We're going to boot over to user B. I will reconfirm version ID and etc OS release. We are still running 4593.2.0. And this system has already had the update staged so that you didn't have to watch me download things over the internet. And this is the flag that you get to see, that this machine needs to be rebooted because an update is available, and that we're going to go to 4593.2.1. So let's update. While the update runs, I'll share with you that FlatCar ships a bunch of different channels of the operating system at the same time. We ship an alpha, a beta, a stable, an LTS, and then occasionally we ship dailies. The reason I bring all of these up is not, ooh, look, we have channels. It's every single one of our channels is fully tested. So no matter what you grab, it has been fully tested with everything we know how to test with. But that goes further than most Linuxes. Most Linuxes run unit-lot tests. They'll test a package. Once or twice, they may test every package in the OS for a certain kind of build against itself. With FlatCar, we run over 100 end-to-end tests on every single release, from alpha on up. Those end-to-end tests are real tests. So it's spin up this cluster, run this workload, make sure this thing works. The real reason we use channels is it lets us gate features over time. It lets us ship incomplete features for users who want to keep up on other things or developers who want to keep working. And it gives us the opportunity for the community to participate by running canary nodes so that when you get to a stable release channel, those nodes have been tested not only by the project, but by users in the community over time. And so you're getting something that has survived both testing of depth and testing horizontally. So we should be able to get back into this node, and we should be able to look at our version again, and hooray, we have moved to 4593.2.1. And let's go put some load on that. Let's uncoordinate. And we will do our magical scale out again. And ooh, we should see FlatCar1 pick up a worker here, or a pod here. There we go. So a question that I often get when I'm talking about FlatCar is, okay, this is great. Other than that failed demo, I love it. But how do I install anything? Because I do need things. And the answer is you don't install like any other operating system, a traditional mutable Linux. You don't package install. Instead, you use something called a systemd system extension. It's an overlay FS that overlays /USR. You can think of it like a container layer, but at the operating system level. And these system extensions also have all of the supply chain guarantees of the operating system. They're immutable, they're DM Verity protected, they can be shipped on their own life cycle or with the life cycle of the underlying operating system. And they're just typically squash FSs that you overlay. They work the same way. You would typically want to drain cordon, but you don't have to reboot. You can do these live, and then you uncordon and put your workload back. We ship 3 different kinds of system extensions. There are 2 shipped by the project. They're really the same, but they have a difference, and then 1 shipped by the community. The project ships 2 or 3 of them by default. They are included in every image and enabled by default, so you have to opt out of those. Those are Containerd and Docker, and then in my case, there's an OEM for Azure with Azure tools. There's also OEM for Camu and so on, the tools that the various platforms underlying them need. There's also a set of extensions built by the project in time with each release that are official extensions that you opt into. And then we've built what we call the System Extension Bakery, where the community has come together to build additional extensions. I'm using some of those in this talk. That's where I'm getting my Kubernetes from. It's vanilla kubeatom. And it's also where, for example, I'm getting Tailscale from, because all of this is on a Tailscale tailnet so that it's not on public internet. But again, all of these are versioned, verifiable, and immutable, and have the same guarantees with regards to you can check one thing and make an assertion about all of the nodes that are using them. And nothing is installed here. It is all composed, as you'll see now. So once again, we're going to need to cordon that node, drain it. Do the thing. There we go. There, it moves over. And we are still on 1. So when I type correctly, you will see that we are running kubelet 133.2. In fact, what I can show you is that every node in this 3-node cluster is running 133.2. You can see it over here on the far right. Okay, so instead of a partition that changes back and forth, we use a symlink and etc extensions. And so you can see here I have 4 extensions loaded. I didn't bother to mark out FlatCar and Docker. So yes, there is a Docker binary on this system right now. Looks like it's just sitting in /USR, but it's really provided by my overlay. The same with kubelet. Kubernetes is linked to Kubernetes version 133.2. These are all being symlinked into extensions Kubernetes, which right now only contains that 133.2. The system can query for updates to those extensions. In this case, it's going to query and find them here. There's a version 12 ZStream available. I'm just going to take it even though it's candidate because we're in a demo. And I've already pre-staged that, so I didn't want you to have to watch it download, but there are tools that would download that for us. I'm going to copy that over to opt extensions Kubernetes, and then I'm going to force that symlink to change. Kubernetes 12, XC, extensions, Kubernetes. All right, I'm going to force that symlink to change. As I said, you don't have to reboot to do this. This can all be done live with just a refresh. So let me type the command correctly. sysext. So what it's going to do is unmerge user and then remerge user. And now, man, I made a typo on both of them, didn't I? Now we have version 12 of kubelet. I need to actually restart kubelet on this system because the systemd unit file has always, and it would just never stop. And we can pop back over here, and you'll see we've already picked up version 12. We can uncordon this, and you can watch me scale one more time. And you'll see Flatcar Worker 1 pick up a node, or a pod. So this is all managed with a lifecycle file here. This tells it where to look for every one of these systemd system extensions. In this case, we're monitoring the Z stream. This is what drives that command to be able to look. Again, this is all driven by your policy, your decision, your choices, not ours. So you decide that. I stepped into my demo a little early there. But what do we have? So what we have here is a non-research project, real thing used by actual companies. This is an older operating system than its presence in CNCF would indicate. We have real enterprise users. We have real community users. If you were paying attention to Open Source Summit North America earlier this week, Microsoft is using Flatcar as the pattern for the thing that we announced called Azure Container Linux. So there are real people paying attention to this. All of this tooling is Kubernetes standard. It uses cluster API concepts. Everything that I've talked about today can be done by Kubernetes operators, daemon sets, and other pieces. I just did it all by hand for the purposes of the demo. This completely follows your policies. So if your node policy is we do one, or we do canaries, or we do this specific workload, and that's how we move through, great. If you're YOLO the whole fleet, great. Like, we don't have an opinion on that. I go YOLO. I did mention earlier that etc is writable. And so you can still get configuration drift. And that's a real challenge. And so we are working right now on incorporating systemd confext. Confext is the idea of sysext, but configuration. So it will make etc immutable as well and give you the ability to compose layers on top of etc. This will close the gap on this immutability piece and should leave us with the ability to take a look at the operating system's version, whatever we wind up with in conversation with the systemd folks about the configuration version, and then where all of the symlinks are pointing for our extensions. And from those simple data points, you can now reason across your entire fleet about the identical nature of all of your nodes and that everything is configured as you actually want it to be, not just as random strings claim. So your implementation needs will vary. But this works, as I said, in any environment that you've got under any Kubernetes that you've got. Thank you very much. I'm happy to take non-Kubernetes questions.
Thank you so much. And yeah, so we have already a bunch of questions that keep arriving. Let me just put up my brightest. Yeah, and it's already there. So any integration with Spiffy Spire?
Hold on.
I can read it. Oh, okay, yeah, it's an acronym, so it's better to read it out for your own.
I'm going to be very honest. I don't know what Spiffy and Spire are, so I am not qualified to answer that. But I forgot to put up the URL. If you'll visit flatcar.org, we'll put the slides back up at the end, I hope. If you visit flatcar.org, you will find our community of amazing human beings in documentation. We're on Matrix, Slack, CNCF Slack specifically, and Discord, and I'm sure that someone who is knowledgeable in those two spaces will be able to assist you.
All right.
Now we don't know the second question.
Yeah, the second question.
Do I like kittens? Yes.
Yeah, the second question is, can Flatcar be used to run stateful workloads with locally attached extra disks, preferably in LVM?
I know it will do it with network-attached disks. I am 99% certain you can do LVM without a problem.
All right, cool. It seems the Slido is reconnecting. Meanwhile, any questions from the audience? All right, Pavel. Right there.
No, no small dogs, just kittens.
Go for it.
Thanks for the talk. I have a question. Like, I don't update anything for a while. I just create a new node and replace the last one afterwards. So like, I can imagine the benefits in like physical environment where you have limited like nodes or limited resources. Like, is there any other benefits or reasons why we prefer update over like new nodes and replacement?
That's really a matter of your policy. There are folks who, in certain environments, find it helpful to keep the same node around. As a terrible example, I would say perhaps you have a good deal on a certain SKU in public cloud. But many large installations drift towards that model where every node is simply recycled and nothing is updated in place. That also gives you better ability to do infrastructure as code and to test things through your CI pipeline. So in my opinion, use immutable, use flat car. That's a fantastic policy.
All right, thank you. Any additional questions from the audience? All right, so we have some more from Slido. So can you compare Flatcar with Talos OS?
Yes, a little bit. So I have not run Talos personally, but Talos, as I understand it, and I am not trying to tell you what their project is, but I want to provide the background I believe I have. They are a unikernel project. I believe it's 7 or 12 binaries that they famously ship with. What they have done is taken a node and stripped it all the way back to a very specific use case, and it is API-driven only. That limits the applications it can be deployed into, but makes it fit as a special purpose operating system, that use case segment, very well. Flatcar is a bit broader towards general purpose, and so we have the ability to not only solve in the use case that they're in, but we can configure additional pieces that are not in their base OS. My understanding is that with Talos, it's pretty much a, if we didn't decide to put it in, you can't have it scenario. Whereas with Flatcar, between system-to-system extensions and the plethora of options that we ship with the extensions in the bakery and in the project, you can choose a lot of different things off the menu. As a personal example, remember, Linux guy, I use unorchestrated containers for all of my stuff. I run everything in Podman with quadlets because I happen to like that. The project provides me Flatcar out of the box running Podman.
All right, thank you. Does Flatcar support live booting via PXE on diskless machines?
Yes.
Okay, we've got that one answered. And what is the way for integrating proprietary kernel modules, for example, vGPU for GPU operator in Flatcar?
We do two things with that. With NVIDIA, we're building the modules and making them available. So they've got all the secure boot keys, et cetera, pieces signed correctly. And then the user space and other components are provided as system extensions. My understanding is that there are some folks working on delivering the modules themselves via system extension, but I don't think anybody has that working outside of the lab.
Yeah, good. Yeah, I think there's a follow-up question to this, right?
Yeah, thank you. Just to clarification, do you still need to rebuild the whole world, like Linux kernel, in case if you want to integrate proprietary model, or you just can inject it with ins mod?
The way that we're doing NVIDIA, you inject it. That's because we have pre-built it ahead of time, and since the operating system's immutable, it didn't drift, so you don't have to rebuild against like whatever random libraries happen to be on that system. I cannot think of, it's DPMG, DPMK. Please help me, I can't think of the acronym.
DPMG, yeah.
Thank you. You don't have to do that. So you're not building this on every node every time, and you're not even having to set it up in your pipeline. We're providing that for you.
Yeah, I would like to put it, there are some options to get kernel modules from vendor. They're not publicly available, even for OS distributor. So they just give you source code with kernel headers, and you have to rebuild it. And the problem of using this approach with Thales Linux, you just need to rebuild the Linux kernel, sign this kernel module, and I was just thinking if it's solved somehow different way in Flatcar.
I'm not aware of that being solved as a recipe that people have published, but it may very well be. I don't tend to need those, so I personally don't have experience there. I'd encourage you to visit flatcar.org. Come see us, talk to us. But that being said, I suspect that the answer should be, don't quote me.
Yeah, thank you.
I would want the answer to be something like, pin to the release process, build a system extension that contains this module that's built at the same time as the release is built. The way that Flatcar releases are built, they're built in a containerized environment where there's 3 levels to separate you from what was inside the container, and then it bootstraps itself. It's Gentoo based. And so I suspect you can inject into that process or append to that process the additional build that you need for this. That's what I would want to start with to answer that question. But I stopped being a developer a while ago, so you should not trust me on that answer beyond this is a good starting point for the conversation in community.
Thank you.
Thank you.
And
Thank you, everybody. Sorry, not just that guy.
Yeah, and I think one last question. How about libraries, etc.? Are they symlinked the same way like binaries do?
I'm not sure I 100% follow this question, but the installation of the system itself looks to you the same as any other Linux, other than the fact that it is read-only. So once these overlays have come in, you can't tell what's being provided to you by an overlay layer versus what is in the base operating system itself. And that was like, when I typed which doctor, it's just sitting in SBin. I can't know that it's coming in from the overlay without digging into the systemd extension configuration. I hope that answered the question. If not, I'm the person with the small child. You can find me afterwards. It is unexpectedly bring daughter to work day.
Thank you so much once again, Brian. Thank you for questions, and especially for Brian. Big applause from Brian. Thank you.
Thank you all.
And just a public service announcement, the lunch break starts now, and we return in 1 hour.
prezentací a začneme si říct tím, co nás motivovalo k tomu dnešnímu tématu, k tomu Kubernetes v Kubernetes. Tak, ještě počkám. Tak, Kubernetes začalo kvůli několika důvodům. Začalo to už před asi rokem a půl, kdy se nám značně začaly rozrůstat počty klastrů. Z nějakých původních 10-15 klastrů jsme se dostali až na 200 klastrů aktuálně. Původní stav, nebo původní klastry používaly kombinaci Terraformu a Ansibleu. Začalo to už pak trochu drhnout, protože to fungovalo ne úplně ideálně, ten Ansible, a nešel spustit třeba na vícero klastry. Refaktorovat se nám to částečně podařilo, ale i tam už to narazilo na své limity. Jakákoliv samoobsluha vůči uživatelům, jsme seznam, máme 1000 zaměstnanců, v podstatě neexistovala. Některé komponenty se vytáčely dokonce v řádu dnů, většinou na externí týmy. Když šlo o aktualizaci, ať už samotného Kubernetu nebo nějakých komponent, tak to trvalo 3 měsíce, tady dokonce 6 až 8 měsíců v případě velkých aktualizací Kubernetes. Přes těch 200 klastrů jsme se rozrostli na 5200 nodů, což taky už v případě nějakých security problémů už není taková sranda, ať už jenom zaktualizovat, zrestartovat, znovu vytočit. Zároveň tam je hromada závislostí, které jsou méně či více skryté. Máme třeba load balancing, který programuje jiný tým a my ho využíváme na APIčku aktuálně, ale to taky už neúplně dobře škáluje. Máme staré verze hromady operátorů a hlavně Cilia. Aspoň znáte někdo Cilium. Je to síťová CNI, obsahuje to kompletně síťování v Kubernetes. A jsme o mnoho verzí pozadu a aktualizace těch klastrů už je docela bolestivá a vyžaduje kompletně všechno zrestartovat nebo kompletně nechat znova vytvořit nějakou orchestrací. A hlavně obzvlášť teďka v době AI toolů security docela dostává na zadek a uspává se to. Security dostává docela na zadek a potřebujeme daleko rychlejší reagovat na hrozby, CVEčka, je toho hodně. Tak, rozhodli jsme se s tím něco udělat a obrázek už ukazuje co? Mimochodem ty obrázky jsou jediný AI na celé prezentaci. Všechno ostatně je dělaný ručně. Zkoumali jsme nějaké upstreamové řešení cirka 2 roky zpátky, ale všechny drhly na 2 věcech. Byla složitá a těžká integrace do našeho prostředí, protože máme vlastní TLS API, máme vlastní DNS, máme vlastní hromadu komponent a zkoumali jsme, tuším, že Gardener a Cluster API. V Cluster API jsme zkoušeli kubeadm provider. Já osobně kubeadm už mám trošku v rezervě, protože dělá občas neplechu při upgradech a nested provider. Nested provider vypadá slibně, ale takhle. Tak jsme vymysleli naše řešení, který se jmenuje po vzoru toho Cluster API provideru Hosted, protože nested už si zabrali oni. A zároveň máme velmi rádi Helm, protože Helmem jde nejen instalovat, ale i odinstalovat a dokáže po sobě uklidit, což v kombinaci s operátorama, který dokážou správně důležité slovo, používat finalizéry, znamená, že když něco smažem v Kubernetu, tak to smaže i mimo Kubernetes. Namátkou třeba DNS, certifikáty a tak dál. Zároveň je to všechno eventually consistent v tom smyslu, že když řeknu, že chci DNS-kový záznam, tak on se vytvoří. Já na něj nemusím čekat, ale vím, že se to někdy provede. Ale mi zahlásím, že se to nepovedlo. Totéž certifikáty nebo nějaké různé další spojení do dalších týmů. Zároveň naše řešení má ještě jednu velkou výhodu, a to, že nám dokáže kompletně nastavit naše požadavky na security. Za tu dobu od toho předchozího řešení vzniklo TLS 1.3, různé další šifry, dokážeme omezit, kdo tam může přistupovat nějaké ACL síťové a tak dál a tak dál. Security tým docela nad tím projektem zaplesal A to už v době prvního prototypu, který vzniknul asi před rokem a půl, trvalo to asi 7 dní práce během normální práce, byla to hromada jamlů, ale to bylo v podstatě celý projekt, hromada jamlů. A kdo si hraje nezlobí, programovala jsem to během obědových pauz. Tak, abychom pochopili, jak ten projekt vlastně funguje, tak si zopakujeme velmi krátkou lekci, v čem je to Kubernetes. Je to sada 3-4 komponent, je tam APIčko, API server, který obsahuje APIčko a nějaký oprávnění nad tím APIčkem. Je tam controller manager, což je hromada operátorů, který zajišťují, že z deploymentu vznikne replikace, z replikace to vzniknou pody, to též kolem cronjobů, kolem dalších, nevím, co tam všechno už v dnešní době je. A pak je tam scheduler, který akorát říká, co má kde běžet. No a v neposlední řadě je tam jediná stateful komponenta a to je APT-style. Všechny ty ostatní komponenty jsou samozřejmě stateless, takže kde běží je úplně irrelevantní, stačí, aby měli spojení na to APT-style. Tak a kdo ví, jak nejlépe orchestrovat aplikace? Kubernetem. Neobjevujeme oheň, ale vyrábíme vlastní zapalovač. Říkám, Gardener existuje, dělá to velmi podobně, ale nám to nevyhovovalo. Tak a jak na to naše provozování? Zavedeme si 2 typy klastrů, takzvaný management cluster. Je první a ten management cluster je v podstatě to ekvivalent klasického kubeadm klastru. Jestli jste někdy zkoušeli doma si vytočit klaster v nějaké virtuálce, nejspíš jste použili kubeadm init, myslím. Zároveň má virtuálky jak na APT, tak i na API, přes statické manifesty. Ty nody jsou součástí toho finálního kubernetního klastru, přes tam pouští první operátory. Ten klaster nepřipojím do žádné cluster meše z bezpečnostních důvodů. Cilium cluster mesh je trošku jiný téma, to zmíním hodně rámcově. Je to na propojení třeba více klastrů daného tenanta, daného uživatele, protože nechceme třeba, aby výdej reklamy viděl, co nemá, nebo nepotřebuje znát identity od full textu, od vyhledávání. A něco podobného máme i v tom management klastru, kdy nepotřebujeme znát nikoho jiného, jenom nás a naše klastry. Zároveň Anycast nebo přístup na to APIčko nám řeší lokální BGPko, Anycastovaný přes Birda, protože největší problém kubernetního klastru je, jak pustit síť, když nemám Kubernet. Nebo jak pustit operátor, když nemám Kubernet. Když rozebereme ty jednotlivé komponenty, tak APT-style je ta jediná stateful komponenta. Bohužel jsme narazili na to, že neexistuje žádný bare metal operátor, neexistuje žádný nic, co by prostě, kam bych dala, tady mám 3 nody, pust mi APT-style a orchestruj si je, jako hotovou binárku. Tak jsme šli cestou statických manifestů, stejně jako kubeadm a v podstatě všichni ostatní. Zároveň na té nodě běží kubelet a ten už namíříme na zatím neexistující API, čímž vznikne v podstatě to, co vytváří kubeadm. K tomu přidáme Kubernetes control plane, což už je stateless aplikace a je to opět statický manifest. Nic dalšího tam není, tam se nakonfiguruje, kde má APT-style, jaký má mít případně APIčka povolený a tak dál. No a přibydou... Jo, dobrý. Pak tam přijdou ještě operátoři, což je Cilium na síťování, cert manager na správu certifikátů, který jsme si lehce teda upravili, aby to byla první věc v tom klastru, protože problém Cilia je, že obsahuje samo o sobě asi 6 certifikátů a nechtělo se nám je dělat v Ansible, tak jsme si ohnuli cert manager, aby fungoval v host networku, aby šel spustit dřív než samotné Cilium. Zároveň používáme dost ve velkém teďka external secrets na stahování externích certifikátů. Používáme external DNS na správu záznamů v rámci klastru. Používáme OpenStackový cloud controller, protože se tomu používáme velkém OpenStack. Používáme machine controller a pak máme čistě naše interní operátory. Tak a teďka to zajímavý, k tomu ten hosted samotný cluster, nebo pro někoho nested, jak se z nás vyspíme. Tam ty virtuálky hostují jen a pouze APT-style. Všechno ostatní běží jako pod v tom teď už popsaném management clustru. A ne jednou, ale 2krát rovnou, protože známe se, odpálíme nějaký Ansible nebo jakýkoliv příkaz a schodíme si síť. Není to poprvé, co by se to stalo. Výhoda etcd je, že etcd nemá žádný anycast, etcd má 3 virtuálky, 3 endpointy a tam si sedí, běží a jenom odpovídá. Zároveň všechny operátory pro daný klastr pouštíme taky v management klastru. Cluster mesh v Sirius nastavujeme jak už daný uživatel, ať je to v rámci tenanta nebo v rámci jenom třeba sady klastru přes 3 datacentra. No a BGP už nám anycastuje přímo klastr přes Cilium. Tak, opět dáme ještě jednou názorně. etcd je zadací virtuálek, to je opět bez etcd as a service, bez operátorů, bez ničeho, ale tentokrát už Kubernetes se nikam nepřipojuje, takže není vidět v žádném klastru. Je to čistě ekvivalent Docker Run, akorát s Kubernetem nad tím, protože Docker Run v systém Dčku mi byl zakázaný. A pak přijde na řadu už samotný APIčko Kubernetu nebo celý control plane, to znamená API Scheduler Controller Manager, a ten už běží v tom management klastru v nějakém namespaceu, který se jmenuje podle názvu toho klastru. Zároveň tam běží Cilium operátor a všechny ostatní operátory, jako CERT Manager, External Secrets, Core DNS, OpenStack Cloud Cloud Manager a tak dál, ale s jednou změnou. Už nemíří přes service account a env, už nemají nastavený, že mají jít na ten klaster, ve kterým teďka běží, ale je tam připojený secret, to je config mapa a secrety s certifikátem a nastaveným envem, že už mají líst do toho APIčka, které běží mimo, nebo které běží paralelně v tom namespaceu a už spravují jiný klaster než ten, ve kterém reálně běží. Tak, aby to, jak jsem už zmiňovala, aby to nebylo málo, tak to máme ještě kompletně v high availability. Takže máme ty 3 OpenStackové virtuálky, na které máme ten jeden management cluster namířený s tím namespacem. To celé zreplikujeme ještě jednou, protože samozřejmě Kubernetes umí leader election na všech operátorech, to přece není žádný problém v dnešní době, určitě nejsou žádné výjimky. No a uživatel leze přes BGPkový anycast. A je mu úplně jedno, kam leze, reálně půlka dotazů leze do jednoho klastru, druhá půlka do druhého klastru. Pro ně to je kompletně transparentní, ty virtuálky jsou sdílené přes daný klastr pro obě ty kopie. Tak, musím říct, že overhead bude velký, ale není to tak úplně pravda, protože naopak nám to umožňuje nasoukat těch nested klastrů, nebo hosted klastrů víc do jednoho management klastru, teoreticky neomezeně, prakticky tam jsou praktické limity asi, typu 5000 podů nebo 5000 nodů v klastru, teďka přesně nevím, kolik tam je ten limit v dnešní době, ale už tam nejde overhead v tom, že by pod každým control planem musel běžet Cilium, který žere 2 jádra, nemusí tam běžet něco kolem logování, což žere další 2 jádra na každý nodě. Teď to běží centrálně a na jedné nodě běží třeba 6 control planeů. A zbývá už tam ta virtuálka s etcd a ta tam byla stejně kvůli Ciliu. Tak, moment, já se musím napít. Samozřejmě ne všechno je zlatý v upstreamu, takže hromada komponent nám vyhovovala částečně, ale nefungovala úplně ideálně. Tak jsme si upravili pár věcí, tady nejsou ještě zdaleka všechny případy teda. Je tady třeba external DNS, jsme si udělali vlastní implementaci proti našemu seznamovackému DNSku, protože samozřejmě máme interní DNS, který je jen a pouze naše. Tam to funguje za pomocí webhooku, kdy oni vystavují nebo očekávají nějaké jednoduché REST API a jenom na ní namíří ten samotný external DNS jako sidecara. TLS management máme vlastní pro sdílený CAčko, který je pro celý seznam, ale samozřejmě my jako uživatelé k němu nemáme klíč, jenom požádáme o podpis certifikátu, který si pak stáhneme přes external secrets. U toho external secrets zůstanou, protože tam byl úžasný bug a pořád je, kdy v push secrets třeba po sobě neuklízí staré klíče. Takže když někdo zmizel z cluster meshe, tak tam zůstal vyset u všech uživatelských klastrů dál. Issue na to v upstreamu je už asi půl roku. Řešení by znamenalo kompletní přepis external secrets. Tak máme opět vlastní patch, který natvrdo přepisuje vždycky, nejenom když má, ale i preventivně vždycky. Potom jsme si psali Cilium synchronizátor, protože máme všude ACLka, security je rok 2026, všude musí být ACLka. My potřebujeme znát nody v těch management klastrech, těch hosted klastrů, protože na DNS běží stejně jako všechny ostatní operátory, běží mimo ten klastr na anycastu BGPkovým. Ale my musíme zabezpečit, aby se tam dostali jen a pouze pody z toho uživatelského klastru a nody, které běží přes host network. No a to získáme jen a pouze tak, že si je budeme kopírovat pomocí nějakého operátoru. Machine Controller je sice upstreamový projekt, ale tam máme asi 10 nebo 15 commitů, který si držíme lokálně. Tam jsme opravovali že špatně detekuje změny anotací u nodů, chybový stavy z OpenStacku kompletně ignoroval a zkoušel každých 5 sekund vytáčet znovu ty virtuálky, když mu OpenStack řekl, hele, už nemám žádný hypervizory dostupný. Na to issue jsem zkoušela vytvářet, ale taky dopadla podobně jak ta z External Secrets. Potom tam je OpenStack Cloud Controller Manager, tam je úprava, a tam se přiznám, že nevím přesně, to dělal kolega, kdy jsme upravovali, že už nejsou potřeba node porty pro load balancery, protože jsme začali používat DSR s enkapsulací v IPIPu, takže už pálíme nějak přímo, já si to přes teďka z hlavy nepamatuju, jak to tam je. No a v Steeliu máme taky hromadu oprav a úprav, už to není tak hrozný, jako to bývávalo. To, co mám změnil to BGPko, tak to bylo opravený minulý týden, zameržovaný konečně, kdy třeba pody vysílali ještě jednou, nody vysílali BGPkový rozsah dřív, než reálně byly ready a zároveň ho vysílali ještě po dobu toho terminating stavu, takže třeba po dobu 40 sekund nefungoval kompletně provoz v části datacentra na danou IPinu, anycastovou. Nešlo alokovat 32kový, nebo 128kový IPv6 rozsahy, což zní divně, ale ve světě BGPka a anycastu je to úplně normální věc. Metriky v Steeliu nám pořád chybí na některé věci, už asi 2 roky na to je issue. Opět nemůžeme opravovat všechno u nás, snažíme se, ale máme taky omezenou kapacitu. Do Steelia bohužel vidí dohromady asi 2 lidi v celém seznamu. Tak a největší úprava, nebo nejdůležitější úprava vznikla přímo v Kubernetu jako takovým, v API serveru, kdy jsme chtěli zachovat uživatelům kompletního cluster admina. To znamená to nejvyššího právní. Jenže uživatelé jsou tak chytrý, že občas přišli a přepsali nám naše operátory. A bohužel oficiální způsob, jak z toho ven neexistuje, tak jsme si dělali vlastní. Pojmenovali jsme to Protected by feature, kdy anotujeme nějaký objekt, CRDčko, deployment nebo daemon set, a v moment, kdy je takhle anotovaný, tak ho může smazat jen a pouze ta skupina uživatelů, která má tu správnou LDAP out skupinu u sebe. Zároveň jsme omezili uživatele pomocí Validating Admission Policy a Mutating Admission Policy, což je funkce Kubernetes 1.30, 1.32, 1.34 a vejš. Tam přesně nevím, tam byla nějaká alfa, beta, jak tam byly. A tam validujeme třeba to, že musí stahovat image jenom z našeho repozitáře, že když vytváří síťové ACL, tak musí zadat takový a takový pravidla. Nemůžou prostě otevřít provoz komukoliv v celém světě, protože dělo se to. Nebylo to ideální, ale dělo se to. Tak, upstream ne vždycky má rád to, co jim nabídneme, protože si říkají, že kdo by byl tak šílený, aby pouštěl Kubernetes v Kubernetu, takže dost často odmítají, pokud není přímo bug fix jako funkcionality, ale třeba úprava Helm chartů, ty nám neprošly snad nikdy, protože každý Helm chart musíme v úzovkách rozdělit. Tím, jak pouštíme operátory mimo klastr, ale ty operátoři se připojují do jiného klastru, tak do toho vnitřního hosted klastru nasazujeme airbag, nasazujeme tam daemon sety, ale do toho management klastru nasazujeme deploymenty. Daemon sety čekají, až naběhne jakákoliv noda, ale deploymenty musí běhat už předtím, typu Steelium operátor, External Secrets operátor, DNS musí fungovat dopředu a tak dále. Pár příkladů, nevím, jestli budou čitelný. Zkoušeli jsme protlačit úpravy do External Secrets. Tam mě velmi rychle poslali pryč, že to není v jejich scopeu nastavovat finalizér na secretu, který přece používají. Nebo třeba v březnu jsem zkoušela procpat bug report na to mazání těch extra klíčů v secretech, to tam visí doteď bez nějakého feedbacku. Naopak v Steelu se nám to podařilo zamerčovat to BGPko, to byl konečně aspoň jeden úspěch, no ale Steelium reálně vypadá takhle, z toho většina z těch closed že jsou out of scope, nebo takový to stale a jsme zavřený, že jo. Takže upstream, pořád držíme ty peče. No a co nejde do upstreamu, to si držíme lokálně. Třeba na Helm charty máme patch soubory, protože rebasování je pain, jako ostatně všechno ostatní. Třeba na Cilium 19.2 máme na Helm chartu 505 změn, nebo 505 řádků v tom patch souboru. A takhle udržujeme v podstatě všechny aplikace, které u nás nasazujeme. Ale zdá se to jako hodně, ale reálně mezi verzema se změní 3-4 řádky, takže rebasovat ten patch trvá 5, max 10 minut a děje to každý den. Takže zase takový problém to ve finále není, ale bylo by hezký to mít v upstreamu. To se nedočkáme. Tak, a jak na tom jsme v seznamu s tou novou architekturou? Jsme ve stavu, že uživatel dostane klaster, kde je adminem, kompletním adminem, funguje mu síť, funguje mu sběr logů, může spravovat své nody pomocí toho machine controlleru a OpenStack Cloud Controller Manageru. Zároveň funguje load balancing přes oktávku v OpenStacku a Gateway API a má tu Cilium cluster mesh, jak se nadiktuje, většinou buď přes svoje klastry, nebo přes tenanta, nebo tak. Efektivně uživatel dostane jen a pouze API endpoint a tam má svůj píseček. Nic dalšího nevidí. Zároveň uživatel nám nemůže smazat ten námi dodávaný workload jako operátory, nemůže nám vypnout žádné nody, protože ani žádné nody nemá v tom klastru, když mu ho předáváme, což zní divně, ale už se nám i stalo, že uživatel si smazal control plane nedostí, že se přece vytvoří znova. Zároveň veškeré tokeny pro přístup mimo cluster nebo certifikáty nebo cokoliv jsme úspěšně, dalo to hodně práce, ale úspěšně se všechno odfiltrovali do stavu, že uživatel nemá žádný token nebo certifikát, který by mu dovolil vlízt mimo svůj cluster nebo se impersonifikovat za jakýkoliv jiný cluster nebo si na lokálu spustit cluster, který se tváří, že je on. Už nemá žádný certifikát, který by to mohl provádět. Zároveň k APT-Style jsou certifikáty privátní, ale na propojení mezi klastrama máme ještě sdílený certifikáty, ale opět těm uživatel nemá přístup. Ty běží opět jen a pouze v tom management klastru. No a operátory nám taky nesmaže, když jsou zamknutý, včetně těch CRDček. Reálně to vypadá jako efektivně sada podů, akorát mezi nimi podama je i to APIčko, je mezi nimi DNSko, je mezi nimi hromada operátorů, včetně Cilia. Tak, začali jsme s migracema, není to tak dávno, je to asi 2 týdny. Je to obrovský bashový skript, protože mám bohužel 2 roky tady na ČVUT a pana Bařinku si velmi cením a jeho znalosti o bashi. Takže v seznamu mi říkají bohužel bashly dost často. Ten skript má asi 300 řádků, běží od shora dolů, trvá to asi hodinu nebo hodinu a půl přemigrovat, ale na výstupu je fakt funkční klaster, který se čím rebootovat nody. Tady nic nedělá. Reboot nodů, protože update Cilia od 3 verze není něco, co by v upstreamu podporovali. A je tam jedna ještě velká výhoda, že díky tomu rozdělení jsme si oddělili uživatelské nody od našich těch control plane nodů, protože nám se dost často stávalo to, že vyšel update containerd, vyšel update kernelu a my jsme museli říct uživateli, hele, vyšel security update, potřebujeme zrebootovat nody, možná ti flapne APIčko. Teďka dáme jenom blbej drain a ten machine necháme znova vytvořit a ono to jak funguje kompletně transparentně pro uživatele. Zároveň to ještě zrychlí ty aktualizace jako takový, protože už nečekáme na vytočení virtuálky kvůli updateu Kubernetu nebo něco takového. Teď to prostě trvá do hodiny třeba pro celý datacentrum, nebo přes půlku datacentra, nebo jak si nastavíme limity v Ansible. Tam nás doslova limituje, měřila jsem to síť, protože mám doma jenom 100 megabit na uploadu a ramka na pracovní stanici 64 gram už je taky málo v dnešní době asi na Ansible. A ještě nám taky umožnilo zadrátovat různé verze komponent k verzím Kubernetu. Tam jsme často naráželi na to, že jsme měli třeba něco moc napřed, nebo něco moc pozadu. Teďka můžeme říct, že k verzi Kubernetu 1.36 nasazujeme Cilium 1.19, k Kubernetu 1.35 nasazujeme Cilium 1.18 a tak dále. Což dřív nešlo a když jsme byli o 8 verzí Kubernetu pozadu a teďka jsme chtěli spát nový Cilium nebo nějaký šílenosti, tak to mohlo trochu drhnout. To už by mělo být vyřešený naštěstí tou novou architekturou. Tak a ještě než nám posledních pár slov. Tak, co byste se asi měli odníst je to, že upstream není vždycky ideální nebo kompletní řešení a je to naprosto v pořádku, protože tam kde upstream končí, vy začínáte, nebo my začínáme, a upstream není posvátný kód a má svoje mouchy a můžete zkoušet opravovat, můžete zkoušet protlačit ty opravy, ale ne vždycky se to podaří a s tím se bohužel musíme naučit žít. Když jsem měla podobnou prezentaci na Linux Days s kolegou, tak jsme se pak bavili s pár lidma po té přednášce a řekli, že mají podobný problém, že upstream odmítá jejich merge requesty nebo pull requesty. Takže nejsme v tom sami a nejste v tom sami. Doporučuji nenechávat zastarat komponenty, protože ten technický dluh velmi rychle naroste. Kubernetes vydává novou verzi každý, tuším, 4 měsíce. EOL je, myslím, že po 14 měsících daný verze, takže máte maximálně 3 verze sklus a pak už je to hodně špatný. Do toho kombinace Cilia, nebo nějakého kalíka, co používáte na síťování, hromada operátorů, externá síť zachrání novou verzi asi každý týden. A ještě důležitější je to, aby to uživatelům fungovalo. Nemusí vidět jak, ale stačí, aby to fungovalo. A občas ta evoluce nestačí a je potřeba kompletní revoluci. Já jsem v podstatě všechno smazala, nechala jsem jenom kus Ansible, který mi vytáčí 3 virtuálky na etc. To jediné, co tam zůstalo v celém Ansible. Tak a hlavně, když nevíte, jak řešit problém, zkuste to spustit v Kubernetes. Tak a cílem prezentace bylo inspirovat několikrát hotové řešení. Na GitHubu to nenajdete, protože každý cloud, u nás to je on-prem, máme datacentra vlastní, je jinačí. V AWS by to fungovalo asi zase jinak. A vlastně jako v GCP, on-prem, u někoho na notebooku, v Kindu by to bude fungovat zase jinak. Takže tak. Tak a nějaký dotazy? Jak se zobrazí tady? Moment. Jo.
Tak za to se omlouvám, že jsem tady těsně minut po začátku. Každopádně, každý host cluster používá svoje 3 VMs pro APT-CD, proč neprovozujete APT-CD uvnitř management clusteru?
Jo, každý cluster má svoje 3 virtuálky. Teoreticky máme nápad, nebo já mám nápad, ještě musím protlačit s ostatníma kolegama, o takzvaných zahoditelných klastrech, kdy budeme mít 3 virtuálky a poběží na nich sdílené etcd přes x klastrů a protože třeba APIčkou může nastavit prefix. U nás to je i kvůli oddělení částečně historický, zároveň to je i proto, že to etcd opět historicky běželo v tom samém OpenStack projektu jako dřív. etcd management clusteru, tam jsme měli problém v tom, že když to poběží v jednom klastru, my ten klaster schodíme, tak co udělá to etcd na síti? Spadne taky. Tam je závislý na tom síťování toho daného klastru. Proto veškeré etcd operátory by museli vytáčet virtuálky s nějakým známým hostnamem, protože chceme mít kompletně izolovaný, aby když něco rozbijeme v jednom klastru, aby to neovlivnilo ten druhý klastr, ten management cluster v tom páru vždycky. Tak. Přetížení control plane jednoho hosted klastru ovlivňovat jiný klastr. Zatím ne. Ono APIčko ku podivu toho nežere zase tolik v porovnání třeba s tím etcd. Tam pokud někdo vydrží, tak to bylo akorát, myslím, že 2x Argo, který úspěšně do toho buší několika tisíc requestama za sekundu, když se to dobře sejde. A i to se žere třeba do 3-4 jader max, takže to se nám zatím nestalo. A můžeme si nastavit nějaký limity, ale se dá dobře škálovat to APIčko, tím jak běží jako pod, je to ten kubectl scale deployment od toho, aby to škálovalo, nebo nějaký HPAčko teoreticky, ale zatím máme v každém klastru 3 repliky, čistě kvůli počtu zón, 3 AZ, jako v každém datacentru. Tak, bus factor, to se přiznám, že nevím, co je.
Jestli je tady autor otázky, tak může doplnit doplňující dotaz, dovysvětlit. Nebo to můžeme skipnout, nebo můžeme přejít na další otázku.
Fyzické nody máme datacentra v seznamu. Na nich běží OpenStack, který zajišťuje vedlejší tým, ve kterém jsem taky jednu dobu ještě působila, ještě než to byl dedikovaný OpenStack tým. A nad tím máme OpenStack API. A ten machine controller volá to OpenStack API, protože to voláme z Ansible, když pořádáte to etcd. Ale je to kompletně v OpenStacku a máme fyzické nody a je jich několik nevím, přes 10 000 těch nodů přes ty 3 datacentra. 2 jsou naše, jedno máme propůjčený. A teď přiznám, že nevím od koho.
OK, super. Nějaké otázky z publika? Super.
Když jste si hráli s tím Cluster API, tak byly nějaké důvody nepoužít ten Capo provider pro ten OpenStack?
Capo je Cluster API provider
Pro OpenStack, no.
Jo, pro OpenStack. To se přiznám, že nevím, to prozkoumal částečně jiný tým a já do toho úplně nevidím, na co všechno došli. My jsme zkoušeli ten CubeADM provider.
Ten Nested, no.
No, a pak zkoušeli ten Nested, ale ten bohužel byl EOL. Proč ten OpenStack používá interně ten CubeADM, nebo?
Myslím, že ne. To byla ty Cloud API věci.
Popravdě nevím, ale došli jsme k tomu, že tady to je z nás asi finálnější řešení, no. Bylo to cirka 2 roky zpátky, co jsme to prozkoumávali.
A vCluster, proč to nepoužili?
vCluster, jestli to pamatuju, tak vCluster, doufám, že se nepletu ještě s ničím jinačím, ten je takový, že to kopíruje ty pody mezi virtuálním klastrem a fyzickým klastrem, nebo jak to tam je? No.
Akorát to se to tváří jako izolovaný klaster, že?
Tam by to narazilo i z pohledu security na to, že tam není ta izolace. Tam není izolace mezi jedním podem a druhým podem, když se sejde nějaká kombinace rance chyby, nevím, kontejnerní chyby, tak jeden pod se dobouchá na ten druhý. Tam ani ten Kässer nepomůže.
OK, díky moc. My už jsme akorát přes čas, kousíček. Každopádně moc krát děkujeme za přednášku. Velký potlesk pro Ashley.
Můžeme spravit fotku? Můžeme spravit. Tady.
S Jurajem Michalka.
Juraj, něco mi to jméno říká. Je to možné. Já jak jsem v Praze, tak... Jo, já posím další. Já nejsem určitě, jak jsem přišel. Jo, takhle.
Druhý je tady, jestli hledáte druhý, nebo co hledáte? Redukce HDMC. Ta tady byla. Ta tady byla. Ta tu byla předtím, ale jestli ji kdo ji potřeboval? Kdo ji potřeboval ten Andrei, neodnesli Andrei? Jo, tady je, dobrý.
Jo, super.
All right. Good afternoon, everyone. Welcome to the talk from guys from KEDA. It wouldn't be a conference in 2026 if we didn't speak about AI and LLMs, I guess. So we have here Jiří Kremser and Josef Karásek, who will give a talk about KEDA and LLM workload autoscaling. So big applause for Jiří and Josef.
Hello, good afternoon. Thank you for coming to our talk. I am Pepa, Josef. This is my colleague Jirka. We are from a company called KEDA, and we work on Kubernetes autoscaling. Jirka, feel free to introduce yourself.
So yeah, I'm Jirka Kremser. I also work with Pepa on KEDA. I'm YAML indenter and making sure that YAML is well formed as well. Before I worked for Red Hat and with KGB and APSA, also Oracle, and it's yours.
I will first cover some basics of autoscaling in Kubernetes, and then I will hand it over to Jirka, who will talk about custom metrics for example, LLMs, but those custom metrics can be used basically for any use case. So typically, when we install any Kubernetes cluster, we immediately also install some kind of monitoring tools, or also alerting tools. And if we don't have autoscaling, basically very often we either see our clusters over-provisioned, and basically we burn money, or under-provisioned, and then we can face outages. And also one of the motivations for having like native autoscaling in Kubernetes was that you have all of the visibility, you have alertings, and you can be sitting on a bus, and you can be getting alerted, and you have basically back then we wished that there's some kind of automatic tool that could respond. And basically making autoscaling part of normal cluster operations reduces number of incidents and avoids over-provisioning. We will focus mostly on horizontal autoscaling right now, which is basically adding replicas of our pods and removing replicas, but also there is autoscaler in Kubernetes which focuses on vertical scaling as well. But in this talk, we will focus on horizontal, and also one distinction is also scaling workloads, but we can also scale nodes and clusters. So also we would like to focus on workloads. In Kubernetes, I forgot which version it was, but there is an addition of a new controller and new custom resource, which basically handles the basic use cases of scaling based on CPU consumption and memory consumption. Since we already in vanilla Kubernetes, we have lots of insights thanks to kubelet about actual memory consumption and CPU consumption of our containers. And also there is a controller which scrapes those kubelet metrics. So it was fairly easy to add this kind of feature for the basic CPU and memory scaling. I'll quickly describe the Kubernetes resource, which is called horizontal pod autoscaler. And basically, you describe the target which you want to scale, and you give it some boundaries, and then you describe the metric you want to use for autoscaling. In here, it will be utilization of CPU. So basically, if right now we want pods between 2 and 10, and the target utilization is 60. And basically, for your use case, you can play with this and try to find like your best number. The idea here is that load, actual load on our application correlates with CPU consumption, and this is tricky, problematic, because it doesn't always work this way. And also, if we looked at scaling based on memory, that would be even more trickier, because imagine URLing which has a garbage collector, or URLing which basically your runtime environment, when it starts, it allocates all of memory and never actually releases it. So scaling based on memory is even more difficult. So let's use the same resource, but try to use a different signal for scaling. So since very commonly we have monitoring stack deployed on our clusters, so let's try to use the monitoring stack for scaling data as well. And all we need to do is deploy a component which we call a Prometheus adapter, and it runs our PromQL query and basically relabels the result so that the API, the metric server, can easily use it. It's a good start, but we are putting more load on our monitoring stack, and also when we try to respond to the higher load in our cluster, sometimes it can be late, and we can actually be users actually can, or the system can be noticeably slower, and in ideal world we have real-time data with no delays, and we can scale immediately. This is unfortunately quite difficult. For some use cases, it is achievable, but those are typically some kind of external scalers, external data sources, typically queuing systems. So let's look at KEDA, which stands for Kubernetes Event-Driven Autoscaling, and it can be used for the same use case as the Prometheus stack before, but it can talk to basically any scaler which you define. There is currently 70 scalers, and you can write your own, or you can just use something. There's an adapter for external scaler, which Jiří will talk about, or one of the add-ons is Open Telemetry, and you can flip the standard Prometheus pool model where you scrape the metrics periodically to push model, and also you can use this to reduce the scaling delay. It has its own CRDs, and also you would deploy 3 components together with the KEDA controller or operator, and the main CRD is called scaled object, where you define the object that you want to be scaling. So in this use case, we will still continue using our deployment, and in this use case, I'm using the Prometheus scaler. So this is basically the same use case as the Prometheus, as HPA with Prometheus like before. But here we don't have to define HPA. Basically, KEDA will create it for us, and once we don't need it anymore, KEDA will also delete it. And you can use different. There's 70+ scalers, and this one, which I'm using, is basically metric, which is completely external to the cluster, which has many advantages. And using KEDA, you can also scale completely to 0 replicas. Normally, if you were scaling based on a CPU or memory consumption, once you scale to 0, you have no more data source. But if you use some kind of external metric, then you can achieve basically, you can scale to 0 and save even more money if your environment allows it. But what if you are missing some scaler?
Yeah.
You can define your own.
People keep bringing some jokes because I need to switch the display to mirroring. Yeah. Sorry. Yeah, looks good. So, but yeah, what if there is a need for yet another scalar that's missing? You have basically three options. You can write the scalar on your own, or you can use the Prometheus scalar, which is pretty universal, and you have to describe the scaling data in terms of PromQL query. Or you can use OpenTelemetry scalar, which is our new stuff. So if you want to write your own KEDA scalar and let other people to use it, you have, again, another two options. Either do it in tree fashion, so you will open a pull request to KEDA upstream repo, and you have to implement the scalar in Golang, and once it's accepted, and other people can use it from their scaled objects definitions. So basically, there are documents, it's documented way how to do that. You implement a couple of Golang interfaces and register the scalar in this scalars_build.go, open the pull request and pray. Or you can do it out of tree, in quotes. By that I mean you have like your own repo, you create your own code, but you have to host it in your cluster. It's going to run as a pod, so as a service. You have to provide either Helm chart or some way to deploy it. And you have to also implement this gRPC interface or contract. So it gives you a power to implement it in a language of your choice. So if it quacks with this interface, it's going to work. And it can be either an external scalar or external push scalar. Yeah, either if it's a pull or poll model. Or you can use the Prometheus scalar. This is an existing one in our ecosystem where you have to put this PromQL query. So given you already scrape the metrics that you want to use for scaling, you can plug it here and it will just work. But there are some pros and cons. So pros is that you have basically zero work here. It's going to work. But it comes with price. Imagine there is some Prometheus in our cluster that's being used by somebody else. It happens, right? You have Grafana dashboards, and each of these panes is bombarding the API with queries. And also we have Prometheus being used for alerting or SREs. And then you have to put also a scaling for that. This doesn't scale. Like if you have multiple scale objects, and each of them periodically asks Prometheus, what's the number? You will soon hit the limit and you will see some timeouts. So this scenario also applies for other metric providers like Datadog and Dynatrace or others. What we suggest to use is a lightweight component called Autoscaling. It's a Golang thingy that takes 50 megs. And basically you can steer only a couple of metrics that are going to be used by KEDA for the scaling to this thingy, and it will talk to KEDA and give KEDA events if it should scale up or down. So here in this example, we can see it's using the push model. So this the Spring Boot application has a environment variable in which you say, hey, put the metrics to the Autoscaling, and Autoscaling will communicate this thing to KEDA. But we support also other use cases. And this long environment variable is part of OpenTelemetry standards. There are some predefined environment variables. And here you are saying basically push only the metrics there. Don't care about traces and logs. So more things about this Autoscaling. In terms of KEDA, it's an external scalar. So it runs as a service in your Prometheus cluster. It's another deployment. It has an OTLP receiver, which allows it to talk everything in your OTel ecosystem. So you can have basically different OpenTelemetry collectors in your picture, which are feeding this OTLP receiver from our scalar. And at the same time, it has a gRPC interface using which it can talk to KEDA. It also contains short-term memory in-memory short-term storage, which allows you to have some support for PromQL. We don't support full PromQL language because seriously, it's a beast. You can do math there, joins and whatnot. But if you do some basic aggregation functions like average, rate, sum, min, count, and labeling works, it will just work. You can preprocess the data either in another OpenTelemetry collector using the transformers, or you can use a feature in KEDA called scaling modifiers, where you can provide formula and do some basic math there. What I forgot, right? You can define the pipeline using different collectors because it has this OTLP receiver. And yeah, well, I think I've got it covered on a different slide. So you can either implement either push-based strategy or pull-based strategy with this model. By that, I mean application can directly communicate the metrics to the scaler using the OTLP protocol, or you can have this collector scraping some metrics from your already existing /metrics endpoint and letting that collector to feed the data of this autoscaler. If you do the this pull model, I would suggest not using this batch processor in OpenTelemetry collector, because if you do that, it will just wait for your data to accumulate and only then it sends, and you lose the delay, basically. You're increasing the delay. So if you want to filter the data, you can use either the feature that's implemented in the scaler directly. It's called a lazy series or lazy aggregates. But it's off by default, but if you enable it, it's not gonna be storing anything in this long-term, short-term storage. But if you enable it, only if people create these scaled objects and KEDA asks for these metrics, it will start the collecting of these metrics or like enabling it to store. Otherwise, if anything with these metrics comes to the scaler, it will just throw it away. And same goes for lazy aggregates. These aggregates means like some average count, because we calculate them on the fly. It's much easier than do it later. And if it's turn it on, these are not gonna be calculated, and you can increase the speed of this thing. And if you want to filter the metrics in your pipelines, you can use filter processors in your configuration for OTL collector, and you can whitelist the metrics that should come to this autoscaler and basically throw anything else. So this can look like your pipeline. It has a different things for different stuff. So your traces can go through some path. Your logs can go different paths. And what you have to do with the scaler is to just plug it to your already existing infrastructure using OpenTelemetry collector. And in this example, I'm showing that under this service, you can have multiple pipelines. And in this example, there is like one pipeline that uses filtering. The top path uses the filter, and the bottom part basically emits everything else to some place, your Prometheus, Silo, or whatever you have, Grafana Cloud. So this way you can steer a bunch of metrics to one route and the other thing to your storage or somewhere else. But hey, the talk was called LLMs, right? So what I'm talking about, OpenTelemetry collector, because it can be used for LLMs, right? Because LLMs is another thing that you can scale. It exposes different kind of metrics, that CPU and memory, but it can work in a similar way. So, but what's different here? This thing needs an accelerator, so basically GPU, right? So if the GPU is not in the cluster, it's not gonna work, it's not gonna fly. So you have to either scale your nodes or GPUs on your own, or use some managed Kubernetes that has a feature that can spawn new GPUs for you using Carpenter, Cluster API, Autoscaler, or whatnot. These things takes ages to start because the weights needs to be loaded to memory. These models are huge. And in our demo, I'll be showing a simplistic scenario where all the weights are being pulled from Hugging Face, so it prolongs the start even more. But this, from our point, is like a micro optimizations. And the landscape is dominated currently by CUDA and NVIDIA. And nice thing about it is that they support this something called DCGM metrics that define some kind of standard, and you can base your scaling on this kind of metrics. It has information about the pod, but it doesn't have information about the service or deployment. So there is some correspondency between Kubernetes object and like model, right? But I would suggest using some high-level framework like VLM, and we'll be showing that, which has this information about deployment as well. Some suitable metrics that can work for scaling are fulfillment, or like how full the KV cache is, number of waiting requests in a queue, or rate of the incoming requests, or others. You can use combinations of these. Oops. The slide stuck. Wow. All right, so the demo, next thing is a demo. It's because it takes a couple of times to do. Oops. So we have a cluster in GCP, and if I ask for nodes, it has two nodes. One should be a GPU, and one should be a CPU one. If I list all the pods, and one of them is that VLM Llama, so it's Llama v3.1 version. It's a quantized version, so it runs on very cheap Tesla GPU. I think I need to first port forward the model, and I can call this is the OpenAI REST endpoint, by which you can ask queries to this LLM model using REST. So I'm asking like KEDA and like continue with the answer, and it says, yeah, whatever. You can do it in a for loop. So now it says once upon a time, and it's continuing the request with the response. And it exposes a couple of metrics. So if I port forward the model itself, should be, I think, this one. Okay, port forward, yeah, this one. No. Okay, so its deployment is called service engine. Sorry, needs to find it. Yeah, this guy. Router service. Oh, okay. So yeah, I know what's wrong. Code forward service from demogods. Yeah, this thing I think needs to be port forwarded. Service. Finally. So if I ask for these metrics and grab for this number of requests waiting, currently there is zero requests waiting. And to describe the scaling infrastructure, we have a bunch of scaled objects. So this is the CRD coming from KEDA. Oh, a bunch, just one, but it has 2 triggers on it. Trigger is something that describes the rules of scaling for the scaled objects. And you can have multiple triggers in your scaled objects. So this one has 2 of them, and one is using the metrics called KVA cache usage percentage, which ranges from 0 to 1, and it describes how heated the GPU is. And the other one is the number of requests waiting. This is the one I was grabbing. And this says that once the model is full and it can't respond with the response, it will queue the responses to the queue. So here we are saying once it's heated more than 50%, scale to 2 replicas, because this target value is 0.5, and if it's like 100% heated, it will scale to 2 replicas. And this thing, target value 30, means that if there is, for instance, I don't know, 90 weighted requests, it will divide it by this target value, and the result is 3, so it will go to 3 replicas. So effectively, the first scaler will scale it from 1 to 2, and the other one from 2 to 3. So just to call the demo, or so, I have a tool called Hey, which tries to bombard the API with API requests. So here I'm saying for 50 seconds, for a minute, bombard the model with this query. And if I show you the number of incoming requests rating right here, it went from 0 to 60. So it should start doing something. KEDA still undercovers HPA, but it does it in a clever way using the KEDA operator, creating these HPAs for you from this scale object. So, but on the HPA, we can see the number for this scalar, and it is like a huge number. This 30 is the target value. Now it's 10,000 or something. So, and if I show you the logs from this Autoscaler, it also should have information about incoming requests, incoming metrics. Right, these are all the logs, I think. Yeah, now it's getting some values. So what should effectively happen is spawn another replica, but this replica it can be placed anywhere because there is no GPUs, right? It's like naive approach of KEDA, just increasing the number of replica of VLLM. Now the hard part comes into the picture. You have to somehow make sure that the GPUs are there. I'm running the thing on a GCP, and it has a autoscaler implemented that adds another GPU node when there's a demand. The demo takes a long time, so I'll switch back to presentation, and maybe we'll be lucky on the end. So just to describe the architecture, we are using VLLM framework, which is a well-known framework for hosting those VLLMs. And nice thing about it is that it has a predefined metrics that you can use for your scaling. Right. This is the architecture on a diagram. There was something called OTel operator that's responsible for creating OTel scalars, OTel collectors. And in our example, it was injecting the OTel sidecar to our model. And this sidecar is responsible for scraping the metrics from the model and sending them to scalar. It's kind of one of the examples. We have different examples in our repo, and another way to do it is using scraping the DSGM metrics itself. But yeah, as I said, it's a naive strategy just to throw more replicas, and you have to take into account different things. For instance, one node can have multiple GPUs attached to it, so if you are scaling the nodes, you have to think about this thing as well. At a KubeCon in London, we had a demo where we're scaling the nodes itself using Cluster API, because KEDA can scale anything that is a scale sub-resource, and Cluster API provides those CRDs. One of them is called machine deployment, and you can scale machines as well using Cluster API. Or you can use Carpenter or Cluster Autoscaler. But these two are more reactive because you need to wait for the pod not being able to be scheduled because of the GPUs that's required for it to run. With Cluster API, you can be more predictive, and you can basically do also things like, hey, scale the GPUs to 0 during night and save some money. But you have to also think about data locality. For instance, one thing to make it faster is to store the weights on a PVC and mount it to our models, and also not to pull it from Hugging Face, as what I was doing. The demo with the script is available, and you can run it also on an Azure, and also you can deploy QN and Gemma models. And also, when I was trying to make the demo work, I figured out there is something called compute capability score. And for instance, some models require this score to be higher than something. For instance, this llama is pretty old, and well, old is like 2 years old or something. So it required only score 7.5, and it basically captures how many features the GPU has, and some models requires more features, so it requires higher score. What I'm trying to say, the GPU is not commoditized as other hardware, and need to think about how RAM you have and things like that. You can make things faster to bake some stuff also to AMIs. For instance, these images for this ML stuff are pretty huge, so you can bake the Docker images directly there. It's kind of anti-pattern, but it will make things faster. Right, we totally neglected the inference gateway and LLMDA frameworks. It's because these are more about routing and load balancing. But we have an example with this thingy as well. If you go to Kedify and examples, we have a feature that can scale from 0 to 1 using Envoy. Because yeah, this thing inherently uses Envoy and Xproc. Because what it does, it basically, before each request, it does yet another request and tries to find the suitable replica of your model with which you want to communicate. And I think that's it, right? Yeah. Let's check the demo. So the node is 4 minutes alive, and I think the model will be still waiting, actually. Yeah, it's still waiting. It takes also almost 10 minutes, so I haven't done this micro optimizations yet. Any questions?
So, any questions from the audience?
Come on, at least one.
Yeah. There is also Slido.
If not, thank you, and you can catch us on the hallway.
Thank you so much. Raz.
Jo, tak pak tadyhle jenom normálně do toho a přisednout si o hodně blíž k tomu, protože ona to jinak nezvládne ta nahrávka. Takže být fakt hodně blízoučku. Že tady je to how to do. Nevadí. Tady je to správně. Jo,
All right. Good afternoon, everyone. I hope you've enjoyed a delicious coffee and returned well refreshed for our next speaker, Andrei, and his talk about passwords and secrets in Kubernetes, how to do it right. Please welcome with a big applause, Andrei.
Hi, and welcome on my talk about secrets, password in Kubernetes. I'm Andrei. I do DevOps consultations, trainings, and I have a company which provides infrastructures, and we can help you with your way into cloud-native tooling, Kubernetes, and clouds. So that's my main focus. I have lots of training for lots of cloud-native topics from containers, Kubernetes, Vault, and so on. So if you want to talk more about my work and everything about DevOps, I have a booth, so you can talk with me there. I will be there today and for tomorrow as well. Tomorrow I will have also a workshop for Argo CD and Cargo. So there will be workshop tomorrow. And I have a large team, or a larger team. I'm not doing everything alone. I have company, so we can help you with like some larger projects on cloud native or DevOps side. We have pretty standard stack based on Kubernetes and those cloud native tools. So we try to use as much as open source we can. This is the stack we use in Sika Labs. And as I've mentioned here, we use Kubernetes, we use HashiCorp Vault, and I will be talking about those technologies right now. So, secrets in Kubernetes. So, why we are working on this topic? The answer is pretty simple. We don't want to have this. We don't want to have secrets committed in Git repositories and store them somewhere like this. This is not super nice, it's not secure, and we want to have a better solution, not just secrets and sensitive data in Git repository. So our goal is get rid of static secrets, secrets from Git repositories, and we want to be ready for a GitOps approach. We want to use a Argo CD and all the GitOps tooling with some secure way how to manage secrets and the best way to get rid of the secrets at all. So how to do that? We will use Vault with Kubernetes, but there is plenty other technologies like Vault. we can store the secrets in some secret storage. I will be talking about like the generic version, so I can run this vault on any Kubernetes, on-premise Kubernetes, or in cloud Kubernetes as well. And instead of Vault, I can use Azure Key Vault, or in AWS, I can use Secret Manager as well with the similar approach, but today I will show you the demo how to use the HashiCorp Vault for that. I will use native Kubernetes authentication. So Kubernetes and every workload in Kubernetes has a workload identity. Every pod has some service account and some identity tied with the pod. So I can use this pod identity to get the secret from Vault, and the secret in Vault can be static or it can be also dynamic. So I can, for example, request one-time password for Postgres connection, which is also useful. And I will not have any secrets in any Git or source code in the repository. So the goal will be like get rid of those static secrets and secrets in code base. We will also create a whole configuration by GitOps principle. So we will use Terraform to configure the vault, and we will create some access control for the secret. So one application can obtain some single secret, and that's it. And we can do it on Vault or OpenBAL in the CNCF landscape. I will be using HashiCorp Vault, but for this example, it's basically same. We will integrate Vault with Kubernetes without any static credentials. So we don't even need a static credential to Kubernetes to Vault. We can integrate a Kubernetes OIDC to Vault. So Vault can accept the identity from the Kubernetes, and if the policy and identity match, we can obtain some secrets from the Vault, which is ideal. And we can do it both way. We can do it from the application itself or with some, for example, plugin to Kubernetes, like external secret. So we will create a secret, a Kubernetes secret from the Vault secret object like for us. And then we can use standard Helms for the connection to the application. So we will have basically no change to existing applications, but we can do it like both ways. So every pod has an identity. If you see here, I run some container with container inside Kubernetes. It's a single pod. And in that pod, there is a path, varan, secret Kubernetes service account and token. And this is a GWC token from Kubernetes internal OIDC issuer. And if you parse this token, you will see something like this. So in the token, you have the identity, you have the pod, you have the service account, you have the namespace somewhere here. So you can determine, you can figure out what is the workload identity, where is this running, it's this namespace, it's this service account, and you can use this this token issued by this Kubernetes issuer to access some external services. We will use this against the Vault, so we will set up the Vault to trust this identity, and if someone presents us with this token, we can obtain a Vault token, and we can get the secret from the Vault. It's very similar to other services, like if we want to access, for example, Azure, we will also use the issuer from Kubernetes here. So we will have the same identity. Instead of Vault API, we will get the token for the Azure Key Vault from the Azure API, and we can also get the secret to the Kubernetes from the other secret provider. The idea is basically the same. We have some trusted identity. We tie the identity with the secret provider, and then we can obtain some secrets from that secret provider. Here in Vault, we have multiple authentication methods. So if I install HashiCorp Vault, and I will have a demo, so I will show you how to do that. We can create an authentication method for Kubernetes. So Vault with this Kubernetes out is configured that if I use the correct Kubernetes issuer with the Vault or internal in this case, so if I have a Vault running in the cluster, it will get the identity from runtime itself and allow me to authenticate myself with some role to the Vault and obtain some secrets. So I have a Kubernetes authentication method, and then I have some role in that method, so I can specify on which service account and which namespaces I want to be able to access this role. In this case, read namespace example, so I can read some path from the secret store by that role. If I am in the correct namespace, in this case, it's a namespace example and service account default, and I can have multiple many those roles. Here is a example of the Terraform policy, which I attach to the backend, the Kubernetes role. So in this case, I've created a simple policy. I can list and read everything in the secret path, Kubernetes example, anything. And because this is a key value store version 2, I have to provide metadata and data here separately, but everything on the path Kubernetes/example/ whatever will be able to read from this row. So, and here I have a boundary to just a default service account, and the namespace is example. So if my application runs in the namespace example, it will be able to read those secrets. If my application will run everywhere else, if it will not be able to get the secrets. And yeah, it has to have a default service account, which is there by default. So how to integrate this in our application, in our workload? We have two ways. One is direct access and direct integration within our application. So if our application, for example, if we know we will use this kind of integration with Vault, for example, we can use some Go SDK. In my case, I use Go for that, and receive the configuration in the application itself. So in the application, we will have like few parameters. What is the role? What is the Vault endpoint? And that's basically it. And we can also use some external secrets, for example, or Vault secret operator, which will mirror the secrets from the Vault into Kubernetes secrets and use those secrets like the same way we can use any other secrets in Kubernetes. This is a simple example how it works. So you can see here we have a simple post request to the Vault API. So you can see here it's a Vault running inside the cluster in namespace Vault. So this is the login API endpoint. So you can see here we are calling the auth Kubernetes login, and we are using a service account token from the Kubernetes, and we are using the role. We have to specify the role. So in this case is read namespace example, and we will get a token, this one. So we will get like larger JSON, but we will use this token. This is the Vault token, and we can use this token to access Vault with some role. And in our case, we can read anything in the example path. So there is a secret called env, and in the env there are like two keys, for just colors, so we can get the configuration here. We are also using this Vault integration not only for secrets, but for some dynamic configuration, so we can just change the configuration in the Vault, and the configuration can be very easily accessed and refreshed inside the Kubernetes as well. So this is the direct access. We can use this, or we can use a Go SDK, for example. So we can see here we have a same thing basically in the Go. So we have a Vault client. We will provide a Vault endpoint. We can read the token, prepare the login. So this is also our role, and the rest is same. We will set the new token to the Vault client, and then we can get the secret here. So that's very, very straightforward. The other way is use some operator. We are using a external secrets IO. There is native operator for Vault, but this external secret work with basically every secret providers, so we can use the same external secrets against AWS, Azure, and so on. And I think it's, even if it's not Vault specific, it's much easier to use it than the native Vault thing. So we are using the external secrets, and the idea is we have a the core principle is same. The external secrets use the some identity from Kubernetes, and it will call the Vault API with that identity, get the secret data, and it will create a secret. So here we have the external secret, which we map against some secret store, and the secret store is pointed into the Vault in this case with specific role. And yeah, this external secret then create a Kubernetes secret, and we can access that Kubernetes secret from deployment, stateful set, and so on. So that's it. Here we can have a secret store. We have secret store and cluster secret store, so we can use cluster-wide connection. For example, in dev environment, we can create a simple solution. So we will create a dev secret store which can read all the dev secrets from the Kubernetes cluster, for example, dev/everything, and we can create a secret from any namespace. Or if we have like production environment, or if we need some more like tightened role, we can create a secret store which is inside the namespace. We will point it on some Vault. We will use some specific role, and then we will create a external secret, which is the like mapping for the Kubernetes secret to some secret store. So we are choosing this secret store. We will create a secret called env, and we will map everything in the path, basically in this path. So we will sync the secret object from Vault on the path example env into our secret. So that's the idea behind the secret operator. We can use this inside a Argo CD. So if I have Argo CD in my code base, there is only the external secret, and the external secret creates this secret. There is an owner reference, so Argo can visualize that. And if you see here, there is no sensitive data in this YAML, so you can have this in Git, and it's fine. So I will show you a simple demo. So let's have the demo. Okay, so I have a demo here. So it's on GitHub. We can create a Minikube cluster. So I will start a empty minikube, and there is a couple of steps. I think this is public, so after the talk you can check this out and try it by yourself. So I will start a vault. There's very simple configuration here, so I can show you the configuration here as well. Maybe I will start a terminal here, and this will be easier. So here we have a vault in Kubernetes. So there is just a simple configuration with just one instance. So let's install. Oh, I will wait until, yeah, we have minikube. So let me check it. kubectl get nodes, and we have like single node here. We will install the vault, and I will put it here. Okay. So we have a vault. kubectl get pods in all namespaces, and you can see here we have the vault. It's creating. Maybe I will start K9s. It will be easier. So I'll start K9s, all the pods. Yeah, and the pod is running. The vault is not initialized, and it's not initialized and not sealed. I have a simple tool here to create the do vault init and save the config file. So I will use that. So it's just a vault init command and vault unseal, and it will store the the vault init file here, which is easier for this demo right now. So yeah, vault is unsealed. The setup is stored here. So we have the token here. And now if you see in the K9s, the pod is up and running. I will start port forward, and let's check the vault. So here we have a vault, and it works. Yeah, we have the out again. No, that's weird. Okay, log out, yeah. And if I try this token, it should work, yes. It's empty, so there's no secret store. You can see here in the access authentication methods, there's just the default token. So let's set up the vault. And I don't want to do it manually by ClickOps. I have a Terraform for that. So let's go here and see the Terraform. I will copy this because I will need the token for the Terraform. And here there is a vault Terraform, and I have some configuration here. So at first I will update the token here, and I will show you what's the configuration for this integration. So maybe I will increase the size. Here we have a Kubernetes out. So I will enable Kubernetes out backend on the default path Kubernetes, and I have to connect my cluster for that backend. So here I will specify this Kubernetes path, and I have to provide a Kubernetes API host. And if I have a in-cluster vault, I will leave the token reviewer empty. It will use the reviewer from the pod, so that's easier. This is the Kubernetes connection. I have also a role here. So this is the role mapping. So in my case, I have some Postgres example with Postgres password. So here I have a read Postgres password role, which I will be using from the cluster, and I will bound this service account. So just default. I don't want to create custom service accounts. I will use just defaults in some namespaces. So I will authorize the namespace default, example1, and Postgres. And this token will have the policies, and the policy is just a read of this Kubernetes/Minikube/Postgres secret. So that's it. If I am in these namespaces, I can obtain this secret from the vault. And that's basically it. I have some extra things like custom user, custom admin, because if I refresh the UI with the token is not cached, so much easier is to use a user pass, and the last file is just this user pass configuration for the authentication backend and for single user. So let's apply that. I have some old state, so I will remove that state because I have a new instance of Vault. So yeah, I will go here and I will apply that Terraform. So Vault Terraform init, Terraform apply, and yes, and I've created the configuration for the Terraform. And one more thing, I've created a secret for the key value backend. So if you go here, we can now use admin, and yeah, it's pretty unsecure. And as you can see here, we have a Kubernetes authentication method, which is crucial for our example. There is the user pass, which is not necessary for this demo. And we have a secret. This is a key value secret engine without any secrets. We can also create secrets using Terraform, but the secrets are stored in Terraform state, which is not ideal as well. So we have like a super simple tool for that. We call it a Vault Filler. So here in Vault Secrets, there is a simple configuration, and here you can see we want to provide this kind of secret, and we have some configuration. For example, ask for the secret, or if this is a Postgres password, we can automatically generate it. So just a generate password, and it will generate it. So then let's put the secrets there. So in this case, let's log in into our Vault. So here I will go to the Vault secrets, log into Vault with the proper configuration. So I will use this one, and here, yeah, we have to log in into Vault. I hope. No. Yeah, the port is forwarded, so yeah, it's a bit slower, but it seems to be fine. And we will run the filler. So I will run this, and it basically automatically generates the password for me. There is no state for this command. It's in our utilities. It's super simple stuff. If I create the secret manually, it will be the same. So here in the secret, if I refresh it, you can see Kubernetes, Minikube, Postgres, and that's it. So I can also create a secret like this, and it's basically the same. So we have the secret here. If you can see here, we have our Postgres password. It's automatically generated. It's fine. So let's try to get the password in the Kubernetes without any like static secret configuration in our Kubernetes example. So in the example, I have a Postgres. I will start with this Postgres first. And here, if you see, there is a stateful set. There is no storage. It's super simple. And we want to get the Postgres password into environment. And here, we can use value from and choose the secret. In this case, it can be much simpler. It can be just env from and read all secrets from that secret. In this case, there is just one, so it doesn't matter. So yeah, we want to read the secret from the standard Kubernetes secret, Postgres env, and we don't have that secret. Instead of secret, we have this external secret, and I have a secret store and external secret here together because I don't want to use like global one. I want to use the specific one only for the receiving the Postgres password here. So in this case, we have a secret store, and we are connected into the secret using a Kubernetes out. We can use different authentications here. So if we need from just a token, we can also use just the token here, but we are missing the whole point about the secrets in Kubernetes like files. So here we will use a Kubernetes out. The mount path for the Kubernetes out is Kubernetes, and this is our role. We can check the role also in the vault. So if you go here into access Kubernetes out, we have those two roles. Here is the Postgres row. I can see the row, and you can see there are the namespace, there are the service accounts, and there will be somewhere the connection to the policy, and the policy is here. So ACL policies, read Postgres password. This is the policy. So this is our secret store. We will use a service account default, and then we will create an external secret which will mirror the secret into the Kubernetes cluster. And we will choose the secret store. In this case, is the same name, and there is a data mapping, and in this case also we are mapping a single item from this key. So if there will be like multiple keys in this Postgres, we will map only the Postgres password. That's it. So let's install the external secrets operator and then try this. So in this case, I will go back here, and we have the external secrets operator. There's just Helm install without any configuration necessary. So I will go here, install it. You will see new pods for it. I hope. Yeah, and we can wait until the operator will be up and running, and then we can create a external secret and check if the secret will be created. I hope the internet will be good for it, but yeah, we will see. And then we can create the rest of the Postgres, and it will be fine. Let's check if there is some trouble, but I think it's just a image download. So describe. Yeah, we are just pulling those images. So I hope it will be fast or faster. Yeah, it's running. We are waiting for the readiness probe, and I think it will be. Yeah, it will be ready soon. Okay. This is okay, and yeah, perfect. Everything is up and running, so let's apply the Postgres, and I will create a namespace for the Postgres example. Oh, I will create all those namespaces together. I close this. So here we have all the namespaces. I can switch to the namespace Postgres and apply the configuration. So example Postgres, and I will apply the external secret first, and let's see how it's done. I can get those objects, so use get, and as you can see here, we have a secret store. You can see it's valid, so the connection has been established to the vault, and in this external secret, you can see the sync status, so the secret has been created. So let's check this, kubectl get secret, and there is a Postgres env. So if I show you secret, here we have the secret, and the password is there. So that's quite nice, and the rest is pretty straightforward. Kubectl apply -f example Postgres, and I'll apply all together. There are some unchanged stuff in the secret stores, and now we will see if I go to pods. We are running the Postgres. There's also like image download, but there is no container creating error because everything works. Let's create kubectl, create namespace Postgres2, and kubectl apply everything into namespace Postgres2, and let's see what happens. Here we have a create container config error. The error is there because we don't have the secrets there, and why we don't have the secrets? It's because the external secret cannot access the vault because we didn't authorize the Postgres2 namespace for the role. So if I show you secret store, secret store, you see two of them. This is the valid. This is invalid provider. If I show you describe, you can see it's not authorized. So it's the valid behavior. Same for the external secret. This one, external secret. You can see here, this is the synced. This is not synced because the missing namespace in the configuration. So this is the first way how to synchronize the secrets using external secrets operator. You can use many operators like this, for example, the vault secret operator. And the other way is use the configuration in your app directly. So I have the second example here. So if I show you the other example here, we have like a counter application. It's my GitHub Andrei/counter. It's like application demo for like my Kubernetes trainings. And here we don't have any external secrets, any environment from secrets. We have some static environment configuration for our application. So we will use a Postgres as a backend. The Postgres is running in the service Postgres in namespace Postgres. And then we have a connection configuration for the Postgres password in the vault. So our application has a vault integration built in the Go. This is Go application. The source is on GitHub, and we want to source environment from this secret, and we also want to use the same role. So in this case, this read Postgres password as well, and the rest is standard application deployment. And we will deploy the application. So I will go back here, and I will use this deployment into the namespace example1. And if I show you the K9s here, pods, you will see the application is starting, and it should run. We have to wait for the image pool, so yeah, we will wait a couple of seconds. Then I have the Another example, just install the same thing into the namespace example2. And if I show you the configuration of that role, here in this role, we have only namespace default, example, and Postgres. So in the example 2, we will have the same trouble as in the Postgres 2 in the previous example. So now you can see everything is up and running. You can see the probes are fine. So try to port forward the application. And if you go here, you'll see application is running. It's connected into Postgres. The counts are stored in the Postgres. It's a pretty simple app. And let's try to deploy the same application into the wrong namespace. So I will go here, and I'll apply it here, and let's see how this works. You can see some errors, so check the logs, and if you see the log, there is a error message. So we are not able to connect into the vault. Now our namespace is not authorized, so the application just fails, and it fails multiple times, and you can see some crash loop back off. Yeah, it can be better error handling for the application, but for this demo purpose, I think is okay. So this is the general idea how to use a vault or some external secret provider inside Kubernetes with Kubernetes authentication. So if I go back here, the summary of my talk is this is, I think, simple solution, and it's built on proven technologies. We can use HashiCorp Vault, we can use OpenBOW, and many other things. You can use your applications, your Helms with no or little changes. If you have like hard-coded secrets, even in those deployments, you will just, for example, use the environment from and mount the secrets from some secret, and that secret will be provided by external secret in this case. And it's great for GitOps because in all the Kubernetes sources or in all the Terraform source code, there is no sensitive information anywhere in Git, so that's quite nice. So this is the link for the demo. It's in my GitHub. So if you just go to GitHub/Andrei Sika, there will be, I think, on the top of the repositories right now. And that's it. Thank you. And if you have some questions, just ask.
Thank you so much, Andrei. There's actually a couple of questions already, so okay. I think I can read it out loud as well. So why still use Vault when they shift to BCL license model from open source one? Isn't it better to use tools like in physical, especially on CNCF open source events?
We use Vault because most of our clients use Vaults and those HashiCorp tools. And I think if you don't like HashiCorp or IBM or the license change, you can use OpenBOW and it will work basically the same, exactly the same. In some of our clients prefer OpenBOW, so we switch some clients to OpenBOW. In some cases, we also switch Terraform to OpenTofu, but right now we are still using both, and we didn't decide any branch. But I think we will probably go with the open source one. So that's it.
Cool. Well, thank you. Fair enough. It's consulting after all, right? So,
yeah. But in this case, I think like the Tofu and Terraform and BOW and Vault, I think the split has one great advantage after all, and it speed up development on both sides. So the new features in Vault or in Terraform were pretty slow before this split, and now it's much faster.
Yeah, definitely. The next question is about what about Vault injection, sidecar of the bot, which will inject the secret from Vault directly to the pod. What do you think about this approach?
Both approaches has own advantages and disadvantages. I think this the injections to the volume is great if your application can read the secrets from some like file system, and you don't have the secrets in environment variables, which is in some cases better. But if your application just needs a environment variables, or if it's like third-party thing which requires a secret object, for example, if you need a TOS for ingress controller, you can use this, and I think it's much easier with the secret mirroring. And yeah, you can read the secret from the Kubernetes API, which is also disadvantage. So yeah, both approaches has own advantages, and we use this one because it's, I think, easier in many cases. But some clients want the injections, or even the injection has, I think, couple of security advantages, like from the if you have like frozen file system, nothing in there, it's, I think, a bit more secure. But yeah, if you are in the cluster, you have the identity from the cluster, I think, yeah, you can receive those credentials anyway. So yeah.
Thank you. Are there any questions from the audience live? Anyone? Just in Slido. There's some in Slido, of course, but all right. The next question. Sometimes it's inevitable to avoid static secrets, especially from or for some third-party services. How would you manage those with Vault?
Yeah, this example is the exact example with static secret. If I get back into the Vault here, this Postgres password is not the Postgres integration in Vault. This is just a static secret. So I just map this exact static secret to the Kubernetes. But the Vault has multiple secret engines. So if I add some secret engines, for example, for the database, for the Postgres, I can receive like a one-time password for the Postgres. But in this case, in this example, that was exactly the static secret somewhere involved. So it's not ideal. If we can use some short, some one-time password, one-time secret for anything better than this one. But in this case, yeah, this is static Postgres password. Okay.
All right. Thank you. The HashiCorp Vault license is expensive. Is there a cheaper way to do high availability?
OpenBAL.
Okay. OpenBAL. Okay. And how to handle an app that expects the dot properties file attached as a volume? Is there an operator that creates such file based on Vault values?
Yeah, there is an operator. The Vault operator can use exactly this. Or if you expect the secret attached as a volume, you can also go to the Kubernetes manifest here, and instead of this mapping like secret to environment, you can create a volume from that secret, and it works basically the way you want.
Okay, thanks. Nice. Right now there are no more questions in Slido. Are there any questions in the audience? Okay, if not, please, once again, big applause for Andrei.
Thank you.
Thank you so much for your talk.
And I will be in the booth, so you can go there and talk about anything, basically.
Definitely, many questions that always follow afterwards. Thank you.
Dominik, těším. Jo, určitě, pohodě. Já si musím rychle odskočit ještě. Tak
All right, if you're coming for the next talk, flowing through failures, durable workflows in Kubernetes, please get yourself seated, and Dominik, Hanák from IBM Red Hat will be with us very soon. Let the speaker come. Perfect.
Bude tam nějaké demo? Jo, na konci.
Jo, protože v tom případě bude nejlepší, když tady ten mikrofon jakoby v ruce.
Jasné.
A pak na konci se vrhneme.
Může se nám připojit.
Jo, jsem.
Tento.
Firefox. Tak, to jsem asi tu full screen. Tak, dobré. Se mi to teraz pokazilo celé. Tak.
Hello?
Okay, yeah, the microphone works. All right, the presentation works? Does it work? Yeah? Perfect. Okay.
Yeah.
Great.
Hopefully.
All right, yeah, I can see it too. So please let me welcome our next speaker, Dominik, Hanák from IBM, who will speak about flowing through failures, workflows in Kubernetes. Please, a big applause to welcome Dominik on the stage.
All right, so hello everyone. I'm Dominik Hanák. So I will be talking about workflows in Java and how you can ensure that if you're running these Java workflows on Kubernetes, that even though you encounter some pod failures, you can still finish the execution of that workflow and you don't lose it. you don't lose the progress you already did. So first, let's just set the ecosystem of these talks, where we'll be moving. So we'll be talking about CNCF server workload specification project, and also in Java ecosystem, which is namely in Quarkus, and the new member of the community, Quarkus Flow. In case you don't know, so serverless workload presents a vendor-neutral, open source, and entirely community-driven ecosystem, which is tailored to define and execute workloads using DSL in the serverless realm. And Quarkus, just maybe to get the picture, who knows Quarkus? Not many? Yeah, so Quarkus is a Java application framework tailored for Kubernetes. So you can build Kubernetes native Java applications, and it comes with lots of benefits and a huge ecosystem of libraries that you can use to develop your Java applications that are Kubernetes native. Yeah, if you are interested more, just check out the links and visit the websites to learn more about this project. So, brief agenda, I'll start, since this is a beginner talk, so I'll start with what is workflow and why would you need a workflow. Then I'll introduce the Quarkus Flow framework. We'll talk about what the durability problem is when you're running workflows in Kubernetes. Show you the solution, and at the end, if the time permits, I'll show you how it works in practice. So, what is workflow? Workflows can be pretty much everywhere. You can define everything as a workflow, from your morning routine or from what your application needs to do. But in general, it's some sequence of ordered tasks, steps, transitions that you do to achieve a goal. Or you can say it's a repeatable roadmap that consists of trigger, task, and some outcome. Or even like definition of the business logic that you want to execute and manage, right? Or we have a definition from Workflow Management Coalition, which formally defines it as the automation of a business process in whole or a part, during which the documents, information, or tasks are passed from one participant to another for action according to a set of procedural rules. Okay? So now that we at least know or we have the general picture what the workflow is, why would we need them? Okay, so that's a lot of there is a lot of like points why would you want the workflow or use them, but I just took for the introduction purposes, I'm mentioning these three. So first is efficiency. So if you define the workflows in an application, you are basically eliminating guesswork. So you put it on paper, you set the rules, you clearly outline what needs to be done, and then like it's clear who does what and when. And since you have the clear definition of what needs to be done, you can easily like redefine or improve in case you identify bottlenecks, etc. So the whole define, implement, execute, monitor, improve loop is available to you. Okay. Next up would be error reduction. Since workflows provide standardized rules and conditions, then they prevent steps from being skipped. So it's like you have a recipe, and if you follow a recipe, you generally reduce errors. And lastly, once you define your workflow, you can easily share it across your application or company or business, which again eliminates error because someone who never did something just follows some sort of recipe, and the outcome should be the same. And lastly, we have automation. So if you define your workflows, you can generally automate them and run them on demand when needed. And when you run them on demand, you can implement things like monitoring, observability, and you can check what they do, how they do it, monitor them, identify bottlenecks, and do things in an automated manner. So based on some input, I execute some workflow and get some result. So this is heavily used in software platforms, like for routing documents, automating backend approval chains, or augmenting data, for example, or notifying people, the right people, based on some condition, etc. And in general, in orchestration and choreography of services, if you automate it using workflows, it's much more predictable. So here is a simple example of workflow. For example, let's say this is your business logic. You need to, you're defining how to request cloud access. So based on some new request, you first log the request, then you wait for manager approval, and then you provision access, okay? So each of these tasks can do different things. It depends on how it is implemented. But all of this is repeatable and should happen exactly the same for each user that is requesting access to cloud. So you can use this then and implement this workflow in your application in case you identify it. Yeah. So to implement it, you can use some engine. We will get to it. But if you never did it and you want to make an application that does this, you would do some if-then-else statements in your resource and produce the result. However, here comes a challenge, which is time. So one of these tasks, or each of these tasks can take time. So for example, the wait for manager approval can take either days or hours or even weeks, based on that if the manager is on a holiday, right? You need to wait. So you obviously don't want to use thread sleep, because you would block the thread on the server, and that is not efficient, right? And you want to use the thread for something else, and you want to manage your resources efficiently. So how would you implement the workflows in your apps, right? You don't want to do it manually. So if you don't know any engine, or you don't know that the engines exist, you would start something with some workarounds. So you could deploy some callback webhooks or some event-driven choreography where you had some brokers that will signal you that the manager finally approved, or some database poller that, okay, when the database is updated, you can resume the workflow somehow, okay? But all of these are kind of like workarounds, because you would need to manually manage the state of the workflow. So, which is you are tangling the infrastructure routing, like cron jobs or database polling, directly with your business logic, which is not ideal, right? This topic is more broadly elaborated on in this blog. Feel free to scan it and check it out. It's from my colleague Riccardo Zanini. And so, naturally, what would be the solution? The solution would be to separate the workflow from the application code, leveraging some sort of engine. So we call it workflow engine. So the workflow engine acts as a dedicated code template for your workflows. So it takes responsibility for routing data, tracking state, enforcing rules, and allowing your microservices application to remain stateless and only focus on the execution. So the workflow engine's value is not just you are drawing diagrams and making it nice, but you are recognizing that the state management, event correlation, or process routing are infrastructure concerns, not business logic. Yeah, so the engine can also handle things like thread safety, managing the threads, so etc. So here comes Quarkus Flow, which is exactly a library that provides you with the workflow engine. It's a lightweight, native-friendly workflow runtime library built on top of Quarkus. So all of the Quarkus benefits, you can read them on the web page, but it's like build-time optimization, developer's joy, the huge ecosystem of very good libraries that you can use in your applications. All of that is bundled when you use Quarkus Flow. This Quarkus Flow brings the service worker specification from CNCF directly into Java. So we implement the service local specification using the Java SDK. And yeah, so it allows you to embed the lightweight workflow engine into any microservice. So if you want to execute workflows in your application, you can do that in your Quarkus applications, you can do that by including this extension. More about Quarkus Flow. So it leverages Quarkus's built-time optimization and also compares natively to GraalVM, which is resulting in nice performance benefits. So the engine boots in milliseconds, which is very good in scale-to-zero architectures. It allows you to define orchestrations using type-safe flow in Java DSL. So instead of writing YAMLs, you are writing Java, which is type-safe. and all of the other benefits that come with Java. Of course, YAMLs is also supported. If you are interested and like YAMLs, you can still use YAMLs. No one prevents you from doing that. But having the type safety of Java and all the benefits is, I think, pretty awesome to have. And lastly, AI is like first-class citizen of this extension. So you can easily implement agentic workflows in your applications. Okay? Basically, we are integrating LangChain4j. So if you want to orchestrate multiple agents and you do something with their output, augment it, etc., you can use Quarkus Flow for that. Is there anyone who knows what LangChain4j is? One, okay. So LangChain4j is a Java library that aims to simplify integrating LLMs into Java applications. So it gives you like API to send requests to LLMs, get some response, control the system prompts, classic prompts, control memory, and all the parameters that you can configure when you are running LLMs somewhere. But this is not the topic of the talk, so if you're interested, there is a link, but just LangChain4j on GitHub. It should give you the result. And lastly, I mentioned agentic workflows. So what is agentic workflow? What is traditional workflow? So in traditional workflow, you follow some explicit predefined software paths, and you usually coordinate services and handle business data. Okay? So it's like choreography of microservices of traditional protocols like HTTP OpenAPI, or reaction to external brokers like via cloud events. And often they are predictable. So if you get one input and all of the inputs from the external services that you orchestrate are same, you get the same output. Whereas the agentic workflows are orchestrating AI agents. Okay, so you have workflows which directly embed some LLMs. So you can do that in sequential or parallel way, but in agentic workflows, you are dealing with non-deterministic output of these LLMs. So you need to like handle mapping of text responses to some Java objects, for example. You need to implement guardrails, have some mechanisms where you need to wait for human approval, for example, etc. So like example could be where you have some draft, revise, and critique loop, which one agent would draft some draft, then will be another agent which criticizes the draft, and the third agent which will revise it. And let's say after third loops, you send it for a human to review, so you actually get some output and some human approves that, yes, this makes sense. So here is an example of traditional Java workflow. Yeah, how it's visible. This is how you do it in Quarkus Flow. So you have some builder, create a workflow named hello, and you have tasks. So it first sets the internal context of the workflow to some message with hello world, and then it will send a post request to some endpoint with this message. Simple, very, very simple traditional workflow. Whereas in the agentic one, you have, again, 3 tasks, but first one is basically listening to an event. Second one is asking agent to do something with the input. And you can see the new hire request and new hire review class. Those are basically the input. So the engine knows that, OK, I should receive this typed, this class. And if it can't, let's say, transfer the input to this class, it will fail you. It will tell you that it's received something incorrect. Yeah, but very simple. Listen to an event, ask agent to process it, and in last step, we are emitting an event with the agent's response. Here are links to our documentation repository. Feel free to check them out. Contributors are welcome. It's quite new. We are approaching 1.0 release soon. So any help, or if you're interested, please check it out. We have a workshop that will take you from implementing basic hello world workflow to augmenting it with events to augmenting it towards agentic workflow. So it's like a whole step from the basics to agentic workflows. And I mentioned here that they are different, but nothing bears you from doing it together. So you can have service and even orchestration with agents. It doesn't really matter, but we can differentiate. Okay, so now to the durability. So since this is all Java, we have some in-memory state, and I have 3 problems that I highlighted, or when we were working with this on this topic that I think are quite interesting. So first one is stateless Java expectation. So Java microservices tend to be stateless. You just want to receive some input, do something with data, send it somewhere, and then you don't really care about the state of it, right? But if you start baking workflows into microservices, you come with that workflows are inherently stateful. So you want to see the workflows are running, post, waiting for something, and they have internal context, which is important to you because it stores the either agent responses or responses from the external services. You want to keep and have it. So, and they tend to be long running. So as I mentioned, the human interaction can take time. The agent response time can be quick, but it can also be long. And also, if you orchestrate multiple services, it can also take a lot of time. So that would be the first one we need to deal with. And so this would be like an example, right? So let's say you have new hire workflow. So you get a new hire request. On the bottom, you see some, let's say, workflow context, the data. You get agent to analyze the CV. It will tell you if the candidate matches the position requirements or not. Then you ask human to review, which can take, again, days. And then you either send him to interview or send him a rejection email, yeah? So if, for example, between the AI analysis and human review, our pod where the application is running dies, we are dealing with the second problem I'm highlighting, is the Kubernetes pod volatility. So pods in which the applications are usually running are ephemeral, so they are affected by rolling updates, node drains, or any unexpected crash, or someone just deletes the pod for you because he thinks it's not important, right? So in that case, when that happens, you are losing your in-memory state. So it's Java application, so all of the state is stored in memory. So progress lost on all the run-learning tasks. So for example, if you waited for human approval, you lost the state. You don't know. You can't resume the workflow from the same point, which becomes costly, right? So if you imagine you have a sequence of agents, and after 5 agents process your input somehow, during processing of the 6th one, it fails. So all of those tokens you wasted in the first 5 agents, you can't easily recover them. Yeah, so for the quick microservice, it doesn't really matter. You restart it, you get the same response, it's fine. However, if you do things like this, you already wasted some money on the AI analysis, so you need to somehow solve this. So the solution would be having a state persistence, okay? In Quarkus, we have a feature which is called state persistence, and it does exactly that. So it stores the state in some checkpoints, and if the pod fails, we are able to restart the state from the scratch. And instead of repeating the process from the start, from the new hire one, we remember that, oh, it was waiting for the human review, so it will just resume from that with all the data that was already present in the workflows context. And while working on this, we try to solve it like this. So we would persist, or the workflow data that is stored in the state persistent would be tied to a pod, so that should solve it, right? Of course not, because if you read the documentation, when pod is replaced, this ID is gone forever, so we ended up with a database of workflow context, workflow states, which didn't belong to anything, so we couldn't restart it. So the solution for that is to leverage the Kubernetes lease resource, which is a stable Kubernetes resource. And yeah, so if we pair it to that, it works. We are able to resume the workflow. So Quarkus flow state persistent works like we are writing the workflow state to a durable data store every time task or completes or pauses. This feature is configurable on demand, and there's lots of configuration you can do. And we support multiple persistence types. So there are some key value stores like Redis infinite span, but also traditional JPA is supported. Note that this affects performance. So if you have like traditional workflows where you care about performance, you want to execute them very quickly, this will affect it, yeah. But yeah, that's like, you need to count with that, right? So if you're interested how much each of these persistence stores affects the performance, we have a performance benchmark in our documentation. So feel free to check it out, but the Redis and infinite span, the key value stores are more suitable for this than the JPA because in JPA you have transactional overhead, which kind of slows it a bit down. But all of this is showcased in this performance benchmark documentation entry from my colleague. So now we have the demo or showcase. So let's see if this works. I'll close this now. Just mirror. Good. Yeah. So how does the demo work? So it's just a workflow. It's just a simple workflow that waits for 30 seconds. We have a like function that initiates the timestamp, and then we delay the operation for some time, which is not really informative for you, I think. It's but we are kind of modifying the workflow context with this data. So and also, if you are interested, you can do it yourself. It comes with a whole README where you set it up and go through it and kind of like educate you how it works in our framework. So I already have everything set up just because to make it more smooth. But yeah, I have it deployed. This is again all done. This is a Quarkus application deployed to Kubernetes locally. And what we want to do is we want to like trigger a couple of workflows. Then I want to delete the pod. So this console is using WebSockets to look for the workflows, and now I need to restart the port forward. This will probably take some time, but not much. So you can see it booted up pretty quickly again. And now, if everything works correctly, we should see a couple of workflows appearing here soon. So fingers crossed. I could have modified the delay to be not 30, but maybe less seconds, but yeah, now we can see. I didn't touch anything. The pod kind of restarted and figured out, okay, I still have a couple of workflows in the state persistence, so it resumed them from the state, and you can see that after that, it's handed to the console. So this is how it basically works. We kind of have like leases that are paired. So when a new pod spins up, the lease is picked up by that pod, and the pod figures out, aha, I have something in persistence, I need to resume it. Yeah, and that should be all.
All right, thank you. Big applause for Dominik. So are there any questions in the audience? All right, if not, there is also Slido available.
You have a question?
Yeah? Ah, sure. Didn't see you back there as I was refreshing Slido. All right.
Thank you. Nice presentation. I have two questions, if you don't mind. One is that this workflow follows some kind of conventional description language, like there is EPPMN for enterprise business management or anything else. That's the first one. And the second one, did you consider storing the state in just pure Kubernetes resources like config maps and stuff like that?
So the second one, if we consider storing them in config maps or any other Kubernetes resources, I don't think so. But I don't think that in a config one it would work that well. I can't give you a clear answer on this, I'm sorry, but it's a nice thing to consider. But we came up that leases would be, like pairing with the leases and having a persistent is the best case because the persistence also can be, like, is a separate thing. So interesting point. And the first one I didn't catch, I'm sorry.
Yeah. So there are some, these, at least one in my time, 15 years ago, there were some these business modeling languages which have a more formal definition, like I remember ABPM, even Java has an implementation, or activity diagrams in UML when it was used back that time. So do you follow some kind of this convention, one of these languages, or how the workflow is defined, or just what are the elements?
So the workflow, we are following the CNCF server's workflow specification. So that is it was at the beginning mentioned, but it's kind of like it evolved from the traditional BPMN notation. Then a couple of years ago, the server's workflow was introduced, which is more like, let's say, like very simple. It's a big simplification on my side, but you can imagine that BPMN is also having like human tasks directly baked into the specification, whereas in a server's workflow one, there is no such thing as a human task, and also, like, let's say the REST, how you do REST calls in BPMN, it's more of vendor specific, whereas in the server's workflow specification, the REST interaction is baked direct in the specification, which is making the it's vendor neutral. So, whereas in BPMN, those REST are really like different vendors did the REST interaction differently. In server's workflow specification, it is directly baked into the spec. And yet there are models, for example, UML specification, it's still being used at the universities. I'm teaching a course where we do UML. So I think it's used, but it depends where. Like, for example, class diagrams from UML are still usable and very much helpful for everything, maybe even use case diagrams. So this is still here. Maybe not not used that much, but it's still present.
All right. Thank you. Since you're out of time, I would like to thank you once again, Dominik, for your talk. Big applause for Dominik.
Thank you.
And definitely feel free to catch up with Dominik in the break. We just need to quickly switch the speakers. right, grab your seats. And please join me in welcoming our next speaker, Martin Bruzina, who will speak about truly highly available hardware, if I translated the abbreviation correctly. Big applause for Martin.
Thank you, thank you. The speech is in Czech, so I think it's okay.
Okay, yes.
Okay, so pojďme přepnout na chvilku do češtiny. Jméno mé je Martin Bruzina, pracuji teďka jako senior platform engineer pro Notino a takový ten internetový obchod s voňavkama původem z Brna, možná ho znáte. A dneska vám povím o tom, jak jsme řešili jeden z našich pain pointů, single point of failure v našem ekosystému container registry. Jenom abyste věděli, s čím jsme se potýkali zhruba, tak v době nástupu, zhruba 2 roky zpátky, jsme provozovali měli jsme uložené naše image v GitLabím container registry, který bylo jedno, běželo na nějaký virtuálce, schovaný v naší síti a už nám to přestávalo pomalu vyhovovat. Neumělo to háčko, nemělo to moc feature, chyběly tam lepší retenční pravidla, nějaké řízení přístupu, OCI podpora a tak dále a tak dále. Byli jsme s tím nespokojení. Navíc nad GitLabem se v Notinu tehda trošku smrákalo, tak jsme řešili, co budeme dělat dál. No a hledali jsme lepší alternativy, samozřejmě. Tak, můj task jako nově nastoupivšího kolegy byl vybrat nový container registry a nějakým způsobem zpracovat POCčko, reasoning a nějaký implementační plán. Bylo to ještě v takový brzké nastupující AI éře, takže dělal jsem to takovou klasickou cestou, kdy jsem otevřel Google a googlil jsem a prošel jsem všechny možný softy, co jsem našel na internetu. Hledal jsem centralizovaný, distribuovaný, všelijaký možný a zaznamenal jsem to do nějaké tabulky a s ohledem na Notino, který funguje tak, že že provozuje vlastní runnery, vlastní Kubernetes on-prem a ukládá data v podstatě taky on-prem, tak jsem přihlédl k tomu, že by asi nebylo úplně rozumný kupovat cloudy, kde bychom ty data ve velkým posílali tam a zpátky. To by se asi našemu network teamu nelíbilo. No a samozřejmě takový běžné věci, airbagy, ADčka a tak dále, a tak dále. Mezi tvrdými požadavky samozřejmě bylo HAčko. A to HAčko se nakonec ukázalo jako docela oříšek. Protože hardware se tváří HAčkově, ale on tak úplně není. A k tomu se dostaneme. Tak, jo, jakmile jsem prošel kompletní nabídku, co byla na internetu, tak jsem se dostal k tomu, že všechny requirementy, které jste mohli vidět na předchozím slajdu, víceméně splňoval jenom hardware. Ty cloudový jsem odřízl z důvodů, o kterých jsem mluvil, a pak tam byly takový všelijaký distribuovaný, exotický, někteří už byli mrtví. V té době byly tam i různý placený, kdy se mi těžko dělá POCčko s něčím, co musím nejdřív zaplatit. Někdy se s těma poskytovateli nedalo ani vyjednávat. Suma sumárum skončilo to tak, že jsme se dohodli, že udělám nějaký proof of concept hardwareu a na něm se mi líbilo, že kromě toho, že to je container registry, která splňovala všechny naše požadavky, uměla navíc pull-through cache a security scanning, který jsme tam původně vůbec v požadavcích neměli. A nadšený jsem z toho byl hlavně proto, že jedním Helm installem jsem to celý rozjel v podobě, kdy to prostě fungovalo, mohl jsem to ukázat, mohl jsem o tom diskutovat, mohl jsem přistupovat na APIčko, bylo to super. Jenomže hardware běží v Kubernetu. A tady začíná problém, jak provozovat kontejner registry pro Kubernetes v Kubernetu. Jenom taková malá odbočka, než budeme pokračovat dál, jenom abyste věděli, s čím jsem se musel potýkat, tak v té době jsme provozovali nějakých 5, dneska už máme 10 klástrů, výhled je, že v brzké době jich budeme mít 50. Běží v tom samozřejmě business critical workflow, workloady, 24/7 logistické operace, hlavně v sezóně. V podstatě jsme doiterovali k tomu, že kontejner registr je pro nás tier 0 služba a je to součást nějaké kritické infrastruktury. A ještě jsme měli nějakou myšlenku, že budeme striktní z pull through cache a budeme tam dělat nějaké security věci, ale k tomu se asi dostaneme až na konci. Tak, když se podíváte do dokumentace na Harbor, tak v HA části uvidíte tady ten obrázek. Takhle nějak si Harbor představuje HAčko. V podstatě na klastru provozujete servisy, deploymenty, pody, všechny ty jejich komponenty. Oni tady na obrázku teda mají vyvedený Postgres a Redis bokem, ale můžete to provozovat stejně v klastru a bude to plus minus podobně HAčkové. A je tam nějaký storage nebo PVčko. A když se na ten obrázek podíváte, tak mě by zajímalo, kolik z vás by to přijalo jako dostatečně dobré HAčkové řešení pro kritickou infrastrukturu provozu mnoha desítek klástrů. To je dobře, že nikdo, protože kdybyste všichni zvedli ruce, tak to zabalíme a jdeme domů. Zvažovali jsme scénáře, co všechno se může stát a co všechno nám může jedna instance Harboru způsobit. Ono musím říct, že my provozujeme 2 datacentra, které jsou sice propojené nějakým síťovým propojem, ale i ten může spadnout, může dojít k nějakému network splitu. A zvažovali jsme i velmi nepravděpodobné scénáře, kdy nám lehne všechno a budeme muset cold startem startovat všechny klástry. No a měli jsme několik možností, jak tady s tím pracovat. První možnost bylo ignorovat háčko, spokojit se s tím diagramem předtím. To mě prošlo. Druhá možnost byla stretchovaný kláster přes 2 datacentra, kdy máme master v jednom, master node v druhém, třetí master musí být samozřejmě ještě v nějakým třetím, aby se vždycky domluvili, kdo je ten hlavní velitel. Jenomže stretchovaný klástry už provozujeme, nějaký historický, a máme s nima víc problémů a chceme se jich postupem zbavit, takže to mě taky neprošlo. Další možnost, dedikovaný minikláster nebo nějaká single VMK někde pochopitelně neřeší problém, takže nic. Možnost čtvrtá byla, našel jsem na internetu nějaký šílený diagram, kdy si někdo dal tu práci a rozpitval Harbor komponenty tak, aby je všechny dostal do HAčka pomocí nějakých proxin a load balancerů a tak dále. Bylo to strašně složitý, po letech jsem to nebyl schopný dohledat, takže autor asi uznal, že to byla blbost a stáhl to. Nemluví o tom, že by tam byly další problémy kolem toho. Pátá možnost. Použít jednu S3 nebo jednu replikovanou S3 a provozovat nad tím 2 instance Harboru. Jenomže Harbor si k těm imageům ukládá celkem dost metadat, takže taky nic. A velmi divoká 6. možnost, abychom se připravili na velmi nepravděpodobný cold start klastru, tak někoho napadlo, že bychom mohli do cache, v takovém případě, že by všechno lehlo, takže bychom mohli do container D cache injektovat image, které jsou nutné pro start toho klastru. Ale je to tak šílený, jak to zní, takže jsme to taky zavrali. Proto jsme sáhli k nějakému dočasnému vítězi, a to je primární instance Harboru v jednom datacentru a replika v druhém datacentru. Každá z těch instancí bude mít svoji S3 storage, používáme Pure Storage v každém datacentru, bude tam nastavená nějaká replikace mezi nimi pomocí pomocí virtuální IP adresy se to mezi nimi bude load balancovat. Ten diagram je malinko nepřesný, protože ukazuje Redis a databázový kláster vyčleněný mimo kláster. My to provozujeme malinko jinak. My máme všechno v tom klastru, kromě S3, která je vždycky v tom datacentru poblíž toho klastru. A máme primární instanci, do které ukládáme image, máme repliku, kam se skrze replikační pravidla ty image replikují. Je nad tím nějaká virtuální IP, která zajišťuje, že je to vždycky dostupný. A tím pádem máme zajištěný nějaký základní scénáře toho, co by se mohlo stát nebo pokazit. Kdyby vás zajímal setup trošku blíže, tak nasazujeme Argem z Helm chartu, nastavuju S3 vždycky v tom daném datacentru. Potom v momentě, kdy hardware je v Argu zelený, tak nastupuje Terraform, který se spustí proti každý té instanci a my máme projekty uspořádané v takzvaných systémech, jestli znáte Spotify Backstage System model, tak tam máme, každý repozitář patří do nějakého systému a v našem případě se vyrábějí v hardwareu projekty, které odpovídají těm systémům. Tím pádem z každého repozitáře přesně víme, do kterého projektu ten daný image patří. Funguje tam i nějaká distribuce, kdy vyrábím hardware robot account a jeho klíče se potom zadávají do CI. V momentě, kdy v GitHubu workflow vyrobí image, tak si jenom vezme hardware robot token a přes hardware robot token to nahraje do patřičného projektu. Tím je zajištěno i to, že ty projekty si nemůžou mezi sebou navzájem vytvářet image. Má to nějakou izolaci mezi týmy a bezpečnost a tak dále. Jo, a důležitá věc je, že jelikož tam neukládáme jenom naše image, ale hodláme masivně využívat pull-through cache, a nejenom kvůli bezpečnosti, ale i kvůli tomu, abychom obešli nějaký problémy, co jsme měli s rate limitama od Dockeru, tak naše původní myšlenka byla taková, že zakážeme všechny ostatní registry a všechno bude muset jít přes nás, přes náš hardware. Funguje to tak, že v hardwareu si nastavíte providera, to daný registry, ať už to je Docker registry, nebo GCR, nebo GHCR, nebo já nevím, jaký jsou ještě další. A v momentě, kdy malinko upravíte adresu toho image, ono si to šáhne do hardwareu a když hardware zjistí, že to nemá, tak si šáhne do toho registry a stáhne si to a potom je to nakešovaný u nás. Může to procházet i nějakým security scanningem a máme to celkově tak nějak víc pod kontrolou. Hledali jsme způsoby, jak ostatním, hlavně vývojářům, zakázat stahovat jakoukoliv image mimo hardware náš. A tato snaha se ukázala být marná, protože tím, že to funguje hlavně přes HTTP, tak tam není žádný způsob, jak bychom mohli blacklistovat všechny kontejnery registry na světě. Takže to uděláme jenom na klastru. Předpoklad je, že nastavíme kyvernem nějaký buď pravidlo nebo něco takového, který prostě zakáže image mimo hardware. Ale i tak, abychom dosáhli toho, že budeme schopni v případě, že by nám opravdu celá infrastruktura klekla a v cachích container D nezůstalo nic, byli schopni nastartovat, tak pro hardware zůstane výjimka a hardware bude moct schopen naběhnout z Docker hubu. To je jedna ze dvou výjimek. Druhá výjimka jsou nějaký Kube API věci, protože to konfigurujeme talosem a podle mýho kolegy se to prej nedá nastavit. A já jsem to dál nezkoumal, abych si nekomplikoval život. Tak, uvažovali jsme i změnu konfigurace na straně Container D, protože tam můžete pro Container Registries nastavovat různý redirecty nebo něco podobného, nebo rewritey, nebo něco na ten způsob, ale po chvilce hrabaní se v Container D jsem uznal, že to nebude můj oblíbený nástroj a opustil jsem to. Tak, to je náš současný setup. Máme primár, máme repliku, máme nad tím virtuální IPinu, funguje nám to dobře. Jsou tam i nějaký end-to-end testy, kdy skrze nějaký pravidelný proces vyrábím image, tlačím ho do Harboru, ověřuju si, že v tom Harboru opravdu je, že je podepsaný, že se zreplikoval, pak ho mažu. Ale pořád s tím nejsem tak nějak spokojený, protože není to úplně ono. V momentě, kdyby se mě cokoliv stalo s primárním klástrem, tak mám problém. Takže teďka to funguje tak, že zapisovat můžu jenom do primáru a číst můžu z primáru a repliky. A v momentě, kdy mě lehne primár, tak nemám kam zapisovat. Chvilku to přežiju, ale po nějaké době by mě vývojáři asi sežrali. Takže co teď s tím? Tady je ještě lepší setup, který je zmíněný v nějakém issuečku Harboru, a to je active replikace. Ten teďka nemáme a myslím si, že asi ani dlouho mít nebudeme, protože náš nepřítel jsou technologický dluh a změny priorit a tak dále a tak dále. Ale jednou bych se k tomu chtěl dopracovat. A když jsem zkoumal, co to obnáší, tak je to doable. Ale má to nějaký problémy. Tady je active replikace. Abych dosáhl opravdový active replikace, tak musím mít konfiguraci obou klástrů naprosto stejnou. Dá se toho dosáhnout Terraformem, má to tu nevýhodu, že to musí být i nějaký drift detection, protože když Terraformem nasetapuju něco a někdo mi tam ručně něco povytváří a začne to používat a nenasetapuje to na tom druhém klástru, tak si bude stěžovat, že to nefunguje. On nebude rozumět tomu proč, já jo. Dá se to vyřešit. Drift detection je jako obecně problém, v Harboru zatím vyřešený není, bychom asi vyřešili nějakým interním toolingem. Pojďme dál. Mutable tags. Mutable tags jsou celkově pain, protože v Harboru při active replikaci to funguje tak, že poslední vyhrává. Když mě někdo natlačí nějaký image s latest tagem do první instance a za chvilku do druhé instance, ono se to zreplikuje i na tu první instanci. Pokud by to dělali nějakým simultánním nebo souběžným způsobem, tak nemáme žádnou záruku nebo způsob, jak určit, kdo má být ten opravdový latest. To je issue, který jsem zatím nevyřešil, tak kdybyste někdo věděli, jak se to řeší, byl bych moc rád. A další problém je, že to nemá bidirectional delete. Ono to umí dobře retenční pravidla, je tam nějaký garbage kolektor, který to pravidelně promazává. Je celkem pokročilej, dá se dobře setupovat, to je v pohodě, ale musel bych zajistit, že jsou nastavená na obou klástrech stejně. Co je velká výhoda, že hardware má infinite loop prevention, to znamená, že když něco nahraju do jednoho, on si to zreplikuje na druhej, ale už se to nepokouší zreplikovat na první. Takže tak.
Right. Díky moc za talk. A jestli jsou nějaké otázky, Jens, tak je to otevřené na slajdu a v případě i osobně. Jo, super, hned jsem tam.
Ďakujem. Ste vravili, že máte dôležité tie imidže, ktoré sú latest pre vás, že tam tie mutujúce tagy vlastne vám robia problém. Tak keď sú to kritické komponenty, ako je to nejaký imidž, tak prečo používať latest? Prečo neísť voči digestu napríklad, alebo priamo urobiť si vlastný imidž?
Já bych chtěl, ale nejsem v tom sám.
Chápem.
Ono to není totiž jenom latest, to jsou různý i něco labely, dokonce se tam naši někteří kolegové rozvášnili s různýma per environment labelama, na kterých si trvají, takže to takový složitý.
Myslím, díky. Nějaké další otázky? Tady super, jedna na slajdu. Jaké máte zkušenosti s pull-through cache? Řešili jste s tím nějaké problémy?
Přiznám se, že jsem s tím žádný problémy neměl. Dokud mě Harbor jel, tak to všechno fungovalo víceméně dobře. Jestli má někdo nějaký specifický problém, tak ať ho zmíní.
Díky. Dobrá, tak pokud jsou další otázky, tak díky moc ještě jednou, velký potlesk pro Martina. Díky za super.
Díky.
So I hope you're comfortably seated for our last talk. And please join me in welcoming Cedric Hnida and Zdeněk Váňa from Cloudera, who will speak about Kubernetes for data platforms at what nobody told you about. So I'm sure you will hear a lot of things that you haven't heard yet. Big applause for Cedric and Zdeněk.
So hi everyone, I hope that you enjoy stories, because we will just try to show you some story. So first, we will introduce ourselves.
So hello everybody, my name is Cedric Hnida. As you can hear, I am French. I have this accent which is very difficult to get rid of. I am a director of engineering at Cloudera, but I was working before in a startup called Tycoon, which got acquired by Cloudera last year. And I've been playing and breaking things with Kubernetes for a long time. And it's fun.
Thanks. So me, I'm Zdeněk. I hope that you know me. I'm working in the Cloudera as the principal engineer. But maybe you know me because of my non-working stuff, because I'm also the CNCF ambassador. I'm organizing Cloud Native Prague meetups, and also this conference, DevOps Day conference, and stuff like that. So yeah, it's about me. And right now, we'd like to share something about the company.
So we are working for Cloudera. Cloudera is a company which was created in the 2000s. It has many enterprise clients which have very strict security and compliance requirements. You don't really hear often about Cloudera, but many of the customers are top financial institutions, banks, states, big pharma companies, and basically many companies are using Cloudera's products.
If you use the big data, so you probably use this us, yeah, especially if you wanted to use your own on-prem or your hardware, because yeah, there is almost no alternative. I can be sure that there is no good alternative for us, of course. So we like to show you also some roadmap about the history of the Cloudera. And it's quite important because Cloudera has some special steps, like that every 3 or 4 years, we can call it like a new start. There is a whole reconstruction of everything. And this year, it's start of the next phase. Yeah, we are making almost one of the biggest change in the company. So it's the reason why we are also trying to hire some people. So you can see that we have also some big names as our clients. So this is just for an overview of which companies are using us and also what we are using it. So
please raise your hand if you think that Kubernetes is easy.
Oh.
Really? So the answer is it can be easy, but it depends under what condition you are running it. So let's imagine you want to run some AI workload, or you want to run some big data jobs, some Spark, some Hadoop, to run some Kafka. So you need a cluster, right? One or more cluster. So you want to get started in a simple way. So what will you do?
Yep, and we will try to show it on some story. So there's some, memes, and it's a storytelling,
So where will you get started? I will go to the cloud. Nowadays, there are many good managed Kubernetes solutions, so I will go either on Amazon, on Azure, or on Google, and I will use their managed Kubernetes offer. Why? Because everything is working there.
Of course. Till it, just stop, or if you are out of your bill. So.
You have working load balancers, you have storage working, all the services of the cloud providers, DNS, certificates, you can have database as a service, encryption also, security. everything is ready for you.
This is good, right? So maybe just think about it if you have some specific data, which are, special GDPRs, or maybe even much more sensitive data like your know-how. So maybe you don't want it to, run it on somewhere because you know some rules of these hyperscalers that maybe they share the data with someone else, or they have to if they are asked for. So maybe you want it to run it also on your on-premise, right? So
now, your life has been easy so far, but you need to have a hybrid strategy. This doesn't come from you, but you are asked to prepare it. So what do you do, Zdeněk?
Yeah, so when I have to store some data, I say, okay, the hybrid cloud is the best solution. Yeah, it's quite easy to run it. So I can start like running on my local machine, and it works. Everything works on my local machine, of course. So then maybe I will try to, use some enterprise solution, like VMware or stuff like that, because it provides me some environment, and then I can run my own Kubernetes cluster there. It's still easy, right? Oh, but maybe you care about the cost, not only because of the VMware itself or other solutions, but maybe even because of if it's not running in the cloud or if it's running on the VMware, maybe it costs the same for you. But maybe if you don't care about the big data, so maybe you will not have any issues with that. But if you have terabytes of data, which should be not only stored but also transferred via wire, so yeah, we should handle something. And of course, if you are running something on the bare metal, so there are some common issues. I hope that every one of you tries to install the Kubernetes cluster on your maybe virtual machines. But have you ever tried to make some performance tests of the storage? Have you ever tried to use your load balancers? In cloud it works quite good, right? But how it's working when you are running on the bare metal? No? So we are moving to the next steps, and yeah, of course, when we wanted to run on the hybrid cloud, of course, we need some hardware.
So now, you need to run Kubernetes on your own hardware. So what do you do? My first idea would be to get a bunch of servers, and as Zdeněk said, install Kubernetes there. I will find a way to do it. IT department will prepare me a bunch of servers, and I will install Kubernetes there, and everything will work fine. But what about storage? How do I get an enterprise solution, something highly available, something performant? I just have a bunch of servers. So how do I get that? I have to make a choice here.
Sure, you can start like, just come on. We can use the CNCF landscape. There are solutions for it, even for the storage. Yeah, you have the OpenBS. You can use the Tsarev for the storage. But maybe it works if you have tens of nodes. But how does it work if you have the thousands of them? Not like 1,000, but maybe thousands of them. So did you try it? No? Nobody?
Nobody try here? Someone. Yeah.
Was it fun? Was it fun to maintain?
Yeah, you start to feel the pain. If you are running on the cloud, everything works out of the box. But once you start to run it on-prem, every abstraction you could use in the cloud, it's not granted anymore. You need to find a solution to get it. You need to do it yourself. And for every cluster, you need to find, again, a solution for this. So we have a problem with storage. There are solutions like Ceph, OpenEBS, or you can use some solution like some boxes like Pure Storage. At least you fix that problem. But what about other solutions for load balancers? Because you need to expose your AI workload or your applications, right?
And there is also another story. I don't know how, if you already have some on-prem servers, maybe even for a longer time. So did you try to order the same server for last 4 years? Or do you mean that if you order the same server with the same setup, is it the same every year when you order it? Maybe not, and you can get some issues, for example, with the firmware, yeah, because of course the server is the same, the name of the server is the same, but it's not working, right? So yeah, having the own hardware, there are some challenges with that, especially, for example, also with the networking, that you have more ports. There's, of course, you ask IT guys to set it up as the same as other servers, but it's not the same.
They will try it, but it takes ages.
Yep.
And they won't do it.
So, and imagine the scenario. We speak about the big data data plane, where there are, at least hundreds of servers, and you can add there more like every week. It's not that you will just add there one time or once per year. You can add there maybe every month, 10 of servers. So you should be pretty sure that it will work, that everything is the same, or it will work. And I'm not sure how many of you tries it, to add nodes. I mean, not the same ones, but as, for example, another tiers in hyperscalers to the cluster. Yeah? And in on-prem, it's even worse.
And then, let's say you solve all these things, but one day, the day before, everything was working fine. And you wake up one day, maybe in the middle of the night, and there's something wrong. Something is not working. You were just a victim of a hardware failure. So what do you do in this case?
Yep. I think you will just pray that it will be fixed automatically, because the Kubernetes should fix everything automatically, right?
Automatically with hardware, right?
Yep. So, but it's it's even not the edge case, because you can have even more issues with that. Because you can, in enterprise world, especially with the sensitive data, you can have also clients which requires running Kubernetes without internet connection. Yeah. So you have to set up your cluster that it works. I mean, not only spin up, but also everything without the internet connection. So yeah, you still use some binaries or like RKI2 or stuff like that for the spin up it, but you don't have the OCI. You don't have anything where you can fetch these things. So
you need to do it yourself again.
Again and again. So you will just reinvent the wheel from the scratch. So
then comes, you have your cluster running, it's pretty big, everyone is happy, but more and more teams start using this cluster, and you start hitting some issue. Maybe one team is deploying something which will affect or break the work and the application of everyone else. And you are in the middle of this. You didn't do this. Other people did it, but it's your cluster, so this is your fault, right? And you start to need to have to handle the multi-tenancy issue. How to achieve that?
Yeah, of course, there are some solutions how you can deal with that. And the first ideas is, hey, there's, for example, sensitive product like vCluster. So I can run cluster inside the cluster. It's cool, right? But
who knows what vCluster is?
No, there are some of them so good. So it's just that, imagine that you can run really cluster in cluster. So you can, separate the control plane. And you don't have to take care about, for example, API element and stuff like that. So it's cool. Maybe it's the best solution. But again, imagine that you have a big company which has not 10 of teams, but maybe 1,000 of them. And yeah, you can run it. There are some companies which are running hundreds of Kubernetes clusters in Kubernetes clusters, but it's hard to maintain it.
But the problem also is that everybody is running in the same cluster. I mean, they get their own virtual Kubernetes, But under it, this is still the same cluster. So if a given team starts to get crazy in terms of storage use, in terms of compute resources usage, this will affect other teams. And you are back to the same problem.
Yep, and also there are issues with the DNS, because DNS is working all the time, of course, right?
All the time.
All the time, and if there is any issue, so it's not the DNS failure, of course. But yeah, I think if you're running storage in Kubernetes in Kubernetes, and you have the big data, so you should take care about the disk performance, because running, you just add another layer, which maybe the performance will really drop down, and you have to deal with it. Of course, there are some alternative solutions, but still, it's not what maybe you are looking for. And mainly, you are trying to find a solution for the isolation of these projects. So maybe you can start like, okay, I can do it like isolation on the namespace base. Then you can add there some rules. Yeah, it's somehow working if you have the good day.
But in the end, it's still the same Kubernetes API, the same cluster, so you are not fully independent from what the others are running.
Yeah.
This is not enough still.
Yeah, because when you kill the Kubernetes API server or the ATCD, yeah, it's dead. So yeah, in this scenario, you have to run the Kubernetes in Kubernetes or create some proxy which will do some rate limiting, maybe also the security hardening. And why are you doing it? Maybe it's better to run a cluster next to the one. So.
And here comes the complexity, because you have a bunch of hardware. Some nodes, they have some disk because you want to have storage, right? You have a load balancer configured, but instead of managing one big cluster, you end up with having to share the hardware between multiple clusters, and this becomes complex. So what to do in this case?
Yeah. As Cedric said, if I have more clusters, so maybe there are some dependencies that I wanted to be communicating cluster A with the cluster B, and cluster B should be communicated only with cluster C, and stuff like that. So there should be some MS, of course. Yeah, of course you can, set up the service mesh. Yeah, it's the best solution. I think you are already using Istio for that.
But at the same time, you want to provide some isolation between the clusters. You don't want that one cluster getting crazy in terms of packets start affecting the other clusters. So the solution for that is to have an abstraction to handle that for you. All this to make hardware behave like the cloud. So there are solutions for that, like OpenStack, for instance, VMware, or Harvester from SUSE and Rancher. So you end up with having hardware, but you give to that hardware some abstraction which you can use to provide isolation. And you can create inside it virtual machines which provides this additional layer of isolation.
Yeah, maybe, in this scenario, say, hey, come on, guys, we shouldn't do that in this way. But you can make a deal that, okay, it's good enough. And then you go to the enterprise customer, and they said, hey, you have to be compliant with the FedRAMP. You know what is FedRAMP? If not, you are a lucky one, trust me. Or maybe you should know the FIPS 140, free. There are some restrictions of what is required for the connections, not only for the connection inside outside of the cluster, but also inside in the cluster, the connection to the storage, and also everything should be encrypted, and then fun happens. Stop.
And the OS must run, the kernel of the OS must run in a certain mode. you are forbidden to use some specific encryption algorithm. All the algorithm you use must be compliant with and certified in some cases with FIPS. And on top of that, you need to build special binaries to work with that. Special kubelet, special containerd, and it becomes really complex.
Yeah, it's fun. It's fun. And yeah, we already mentioned that you can have also, the most problematic part, and this is the way that clients, ask for that. Hey, I'd like to run the Kubernetes cluster without the internet connection. So you have to pack it up everything that you can provide them as the package. Yeah, and imagine that you will get hardware, and you have to spin up there the Kubernetes. They don't care about how and how it will be working, but it should be high availability. It should be self-healing. Yeah, it should be almost everything, and you don't have the access there. You can't even get the logs. You have no visibility. So
no visibility, exactly.
Yeah, no visibility. So yeah, you have to create like, maybe it's not only PaaS, but we can call it like SaaS on-prem without internet. So yeah, it's quite funny. And of course, there are some solutions how you can deal with it. We will show it to you in the end that how we will do that with it, but we will just try to say the story why we ended up with our solution. So it's not only about when you spin it up, because of course spin up is the crucial part, but you have to also operate it, right? Because again, it can crash. So what can crash?
What can crash? What do you think?
Any idea? No?
No idea.
No, just look at this previous picture. They are not the same. It's changing, right? There are some cross with some comments. What can be changed? So okay, this is the slide. So Cedric just try to show it to them.
So you have been running your cluster for some time. Everything is fine. And then one day, it doesn't work. etcd starts to be slow. Your application, depending on it, don't work anymore, and you don't know what to do.
Yeah, and also sometimes clients said, okay, I need an upgrade of the cluster because there are some security issues. And you can try to say that, hey, it's offline, so why you take care about it? Say, hey, no way. You have to provide us the upgrade without connectivity. So yeah, it's fun that you have to prepare another binary which he can just run it on maybe on his laptop, and then he can upgrade the thousands of nodes. And
sounds easy.
And you can imagine that upgrading. How many of you tries to upgrade more than 100 nodes in Kubernetes cluster? Once, two, 3. In one cluster. With petabytes of data.
Did it go well? Raise your hand if yes. Yeah, amazing. Please come to us.
Yeah, you can also share your pain. So, yeah, it's really not easy because it's fun when you have tens of servers, because it takes like maybe an hour. But if you have 1,000 of them, so maybe it can run days or weeks, even weeks. And of course, you have hardware, so you can imagine that if you're running the upgrade for a week, someone can crash. And then what happens if you upgraded the node and it crashed, or maybe it crashed during the upgrade, and it happens to more of them. So you have to make also the recovery mode, and again, without no visibility, without no internet access. So again, it should be self-healing. Cedric.
So it's very interesting now because you started with a task to run some AI or some big data workload on the cloud, and everything was working fine. Then you were asked, please do the same thing in a hybrid strategy or on-prem. And you were supposed to only care about the workload, and you ended up caring about much more things. You had to care about hardware, about DNS, about certificates, basically everything which was granted to work for you on the cloud. You didn't have to care about it. You needed to care about it now.
Yep. So one more time, look at the previous picture, and what it changed, right? It seems very similar. One more time. So it's fun, right? So maybe we can, move on. So, the best idea is, to provide Kubernetes everywhere, of course, right? On the cloud, on-premise. So maybe we can share how we did it, right?
How we did it.
How we did it. So, Cedric, start from the, the lowest layer.
So we tried many things over the years. Some things didn't work, especially running Kubernetes directly on the hardware. Because of all this complexity, despite all the recent changes with Redfish and all this API to make the hardware have some API, we are still not there yet. So what worked for us was to really have some abstraction, which made the hardware usable, and to make it look like a cloud provider. What we found really stable in terms of isolation or functionality was to run a private cloud solution. We are big fans here of OpenStack, for instance. So you end up having an OpenStack cluster. It provides you many of the solution in the same way as a private cloud does. What does it mean? Load balancing, network isolation, storage, both block storage and share file system, for example, for your AI workload.
So is it clear, right? So you will have bare metal and install OpenStack on that.
Easy.
Easy, right? But no. There are some issues that you don't want it to run the OpenStack on the bare metal. So why?
Well, you want to run OpenStack on bare metal, but this is not exactly what you want, because you need a true hybrid strategy to combine. I mean, you cannot do everything in one place. You want to combine all, like Kubernetes clusters running in different locations, some of them on-prem, some of them in the cloud.
So how we can make it working? So there are one solution which we tried and it works, at least for us, for our big clients. We just said, okay, we will run the Kubernetes on bare metal, and then you install the OpenStack into this Kubernetes cluster. It's crazy, right? You are just add one more layer, but why? But we already said it. If you wanted to provide like the cloud native from the infrastructure perspective for the hardware, so it's one of the way how we can achieve it. And if you wanted to be really pure hybrid mode, we thought that it's the only way, or working way, in quite enterprise environments. But it's not all, because right now, so you install the Kubernetes on the bare metal. You install OpenStack to this cluster. But it's OpenStack, and you wanted to provide the Kubernetes. So you can just install the Kubernetes into the OpenStack. So you have 3 layers, like Kubernetes, then OpenStack, and then the Kubernetes. It sounds, again, crazy, right? Because you are just adding the complexity of it. But again, imagine that you are trying to add, servers on real time. They can be not only killed or maybe dying all the time, but also you wanted to provide a way how they can, plug in the new ones, especially even every week. So how we will do that? Cedric. What is the abstraction layer that, right now, imagine, I'm just installed the Kubernetes cluster, right? Or Kubernetes on the bare metal. Then I install the OpenStack. This part is clear. But what about the next layer, the Kubernetes in the OpenStack?
So the Kubernetes in OpenStack is you get the cloud provider experience. It's working like in the cloud.
Yeah. And is it the same Kubernetes as, is the same Kubernetes, in the first layer and the third layer? Or should I use a different one? Because
it's the same Kubernetes.
Yeah, because, same Kubernetes, wait. When I install the first Kubernetes, I should care about the disk encryption, right? Because it's on the bare metal. I should, try to figure out the upgrade lifecycle, and that's it. And then, how can I use the same Kubernetes cluster, in both layers? So, and it's one question. And second one is, when I install the second Kubernetes, so can I run the application inside there?
Inside the second Kubernetes?
Yep.
Yes.
Or should I create another one? I mean, the 4 layer. So.
Yes, you can.
And how? Is there any challenges for that?
No, because you solve the abstraction issue.
Yeah. So does it make sense for you? No? It's quite common. Yeah, I know, it's complex. But you should go to our booth and we can try to explain to you more. So maybe we can summarize it. Yeah. So we try to explain you that we found that the only way how we can achieve this enterprise grade, it's some union. Help me, Cedric. Union cover scenario where you can combine the Kubernetes, the OpenStack, and also another Kubernetes, and with, of course, some CNCF tools about it.
Yeah, hardware is difficult, so you solve the abstraction, and on the top of that, we came to realize that if you run Kubernetes in different providers, they end up being different. So what worked for us in this scenario was to have the same Kubernetes distribution everywhere. Because AKS, EKS, and GKE, they all work in a bit different way, and this end up affecting you. And what really worked for us was to build an abstraction to get really the same stack everywhere, which means that the workload we will be running on this Kubernetes would work in the exact same way everywhere.
Yep. And that's it. Right? Again, I can see that it's 100% sure and clear. Everyone knows how we are running it, right? And it's the reason why there is a space for your questions, because I hope that there will be more of them. So, is there any question?
What is the deepest level of Kubernetes sorry. My question is, what is the deepest level of Kubernetes inside Kubernetes have you achieved, and what stopped you at this point?
Practically, you can go very deep, hundreds of layers. Does it make sense? Not really. Is it fun? Yeah.
I think that from my experience, I think we started figure out some issues with, I think, 9 or 10 layers, that it starts, happens that some API calls are, disappeared randomly. So yeah, I think it's not a good way, to combine more layers, like in Kubernetes or even stuff like that. But if you are combining like 4 or 5 in a good manner, so there is almost no performance drop. So it's no issues with that.
So what you said was, if you understand, the advantage what you propose is the same flavor of Kubernetes runs exactly same way in your hardware and across all the cloud providers, because you abstract how you build on cloud-specific ways with a standard way of putting the Kubernetes clusters, correct?
Exactly.
Right.
To provide the same experience everywhere, no surprise.
Right. But is there a cost issue when you run on cloud? Do you actually manage that separately? And then the other thing is, how do you manage the scale? If you're running, on-prem, how do you scale? Because cloud gives you elasticity, but it comes at a cost. So I run some workloads locally. How do you manage that?
That's an excellent question. How to scale that? Because you have a set of servers. This is why here we'd like to have something on top of the hardware, because this hardware is here, it's available, so you like to have something to make it, let's say, elastic, that you have this pool of hardware, it's always here, and you make it like an API. So if a given cluster in a given workload needs resources, it can scale inside the dedicated pool of hardware. Then, if you need bigger elasticity, then you can fall back on the cloud, because what you have, of course, the cloud is, we can say there is unlimited space available on the cloud, practically. Okay. Truth to be told, sometimes it's not true. So the idea is you have your basic set of hardware on-prem, and if you have a burst in demand, you can scale in the cloud.
Great. Thank you.
Thank you. We have a bunch of questions in Slido. So let's start with the hot topic that got 1 like. It's 0. So what would make you reject Kubernetes as the target platform? What would make you reject Kubernetes as the target platform?
Because Kubernetes is complex. Kubernetes is not the solution to everything. If you run a bunch of lightweight applications, you will end up spending more on running Kubernetes when you could just have a private server or a Lambda doing the same thing for a fraction of the cost. So Kubernetes everywhere, yes, but no.
Thank you. The next question is also Kubernetes related. What observability signals are must-haves before calling a Kubernetes data platform production ready?
Well, there are plenty of them, but maybe the better question is what is common to be deployed, or what is common to be measured. Because of course, Kubernetes provides you some, basic metrics which you can, take care about. You can also install there some Prometheus and stuff like that, and look at these metrics. But in reality, you don't have to take care about it because you are using the OpenStack, and then it's the question, because when we speak about if you do.
What observability signals are must-haves?
Can you repeat Right. I agree with the answer, yes.
We can also start from the end and define production ready.
We still have some time?
Yeah, I think we have time for like 2 last questions probably. How do you handle node failures when storage is attached to specific zones or nodes?
So specific node is an easy question because as we discussed, we want hardware to behave like a cloud. So in any case, you can migrate the workload of the VM somewhere else. Then about zone, it's more complicated because if a given zone is unavailable and your hardware is running in that zone, the only answer to that is to build a solution based on redundancy. That if a certain zone goes down, you have another one ready to take over, right?
Maybe I have small things, how do you define zone? There are also some hyperscalers which, provides you free zones and it's running in it's running in the same building, but just on 3 different floors. It's in Asia, one of the hyperscalers.
Okay. I think the last question, because we will have to end for the group photo. So let's pick up this one. What if you just quit the job and went to work on a farm instead? What? Yeah, it's really there. I see the astonished face. What if you just quit the job and went to work on a farm instead?
I'm already working on it.
On quitting or farming while working for Cloudera? Nice. All right. Thank you so much. Big applause for Andrei and Zdeněk once again. Thank you.
Thank you very much.
And everyone who wants to be in a big conference group picture, please head in front of the building. If I'm not mistaken, we will be taking a picture in like a minute or 2 there. Thank you. And authors of those remaining questions, feel free to catch up with Zdeněk. He's, of course, available to answer it in person.